Is Gede Adi Putra.
And my name is Lucia Versli Sunario. On behalf of Indonesia Civil Pilot Academy of Banyuwangi, we would like to extend a warm welcome to our honorable speakers and guests for taking the time to attend this event. To our honorable audience, let us praise and thank the presence of God Almighty for the abundance of grace and joy, so that we can still gather in this place without any barriers at all.
Ladies and gentlemen, let us also take a moment to express our immense gratitude to all the organizers who have made this seminar possible. We are truly thankful for the efforts and contributions to make this event successful. Ladies and gentlemen, we would like to remind you to turn off your electronic devices so we can give our undivided attentions to our speakers. And ladies and gentlemen, let us take a brief moment to honor our great nation by singing our national anthem, Indonesia Raya. We please you all to stand up. The next song, Himne Perhubungan.
Takwa kepadamu, oh Tuhan yang Maha Esa. Sejak manusia terbencar di pulau gunung dan lembah, rindu jasa perhubungan di darat, laut, dan udara. Abdi negara Pancasila melayani dengan iman cinta.
Thank you to our audience. You may all take a seat. Ladies and gentlemen, now we will hear the greetings from the Director of Indonesia Civil Pilot Academy of Banyuwangi, Captain Daniel Dewantoro Rumani. Time and place is yours.
dear region of Banyuwangi district or representative, Professor Dr. Insinyur Aisyah Enda Palupi, MPD as speaker, Prof. Endra Hermawan, PhD as speaker, Yosafat Etuko Sri Sumanto, PhD as speaker, Prof. Zainal Arifin Nasibuan, MLS, PhD as speaker, Prof. Said Ahmad, PhD as speaker, Rector of Bakti Indonesia University, and all esteemed participants of the International Conference on Artificial Intelligence, Navigation, Engineering, and Aviation Technology, Icaneat 2023. It is with great joy and pride that I, as the Director of Indonesian Civil Pilot Academy, welcome you all to the inaugural International Conference of Artificial Intelligence, Navigation, Engineering, and Aviation Technology, Icaneat 2003. Today, we gather here at our esteemed institution to embark on a journey of exploration and collaboration, bringing together the brightest mind in aviation technology from around the world. We are proud to serve as the host of this historic event, providing a forum for exchange of knowledge, ideas, and experience in the disciplines of artificial intelligence, navigation, engineering, and aviation technology. This conference topic reflects our shared commitment to pushing the boundaries of innovation and embracing the transformative power of this dynamic field. Icaneat 2003 serves a testament to our dedication to advancing of aviation education and research. By bringing together experts, scholars, industry leaders, we create environment that foster dialogue, inspire creativity, and propels us toward the new frontiers of knowledge. It is here, within the walls of Indonesian Civil Pilot Academy, that we have chosen to shape the future of aviation technology. Icaneat 2023 will feature a diverse range of presentation and panel discussion that delve in latest advancement, emerging trends and challenges in artificial intelligence, navigation, engineering, and aviation technology. We have curated a lineup of esteemed speakers who will share their insight, expertise, and groundbreaking research, provoking thought and igniting innovative ideas. As participants, each of our plays a vital role in the success of this conference. I encourage you to actively engage in the session, ask thought-provoking questions, and contribute the vibrant discussion. Your perspective, experience, expertise, and invaluable in shaping the discourse of driving meaningful progress in our field. We received 47 article papers in Icaneat submission, accepted 43 for publication as proceeding. Selected papers will be published in international journal indexing, sites such as Copernicus and Google Scholar, while the others were denied due to scope of limitation. Icaneat 2023 is more than just an academic gathering. It is opportunity to forge connection, build partnership, and strengthen the bond collaboration. I encourage you to take advantage of the networking opportunities available and engage with your peers, colleges, and industry representatives. Together, we can foster a global community that transcends border and works toward a common goal of advancing aviation technology for a better term of society. Before I finish, I like to offer my heartfelt appreciation to organizing committee, our co-hosts, and the tireless team of volunteers who work relentlessly to make this conference a reality. Your enthusiasm, dedication, and continued support have been critical realizing Icaneat 2023. Once again, I extend a warm welcome to all participants of Icaneat 2023. May this conference be able to catalyst for innovation, collaboration, and excellence in this field of artificial intelligence, navigation engineering, and aviation technology. Let us embrace the opportunity to shape the future of aviation together. Thank you very much.
Thank you, Captain Daniel Dewanto Rumani, for the delightful greetings. You may return to your seat. Ladies and gentlemen, now we would like to invite the representative of the region of Banyuwangi, Dr. Randus Dwianto, to open this event. To Mr. Dwianto, time and place is yours.
Distinguished audience of seminar participant, because my English is very minimal, please allow me to read the speech of the region of Banyuwangi. Once again, please allow me to read the speech of the region Banyuwangi. Good morning, distinguished guests, ladies and gentlemen, and welcome to Banyuwangi. It gives me great pleasure to welcome you to first the International Conference on Artificial Intelligence, Navigation, Engineering, and Aviation Technology, which is being hosted by the Indonesia Civil Pilot Banyuwangi chapter. I would like to send our warmest greeting to all the participants who have traveled from near and far to attend this conference on behalf of the regional administration and people of Banyuwangi. Your presence here demonstrates the world's strong and growing interest in artificial intelligence, engineering, and aviation technology. This conference together prominent experts, academic, engineer, pilot, and industry partners to discuss and exchange ideas on the most recent advancement and future direction in this interesting domain. At this time, I invite you to engage in meaningful talk from new alliances and envision new possibilities for advancing this technology for the benefit of humanity. We are pleased that the Indonesia Civil Pilot Banyuwangi Academy in hosting the conference in Banyuwangi on Java's eastern coast. Our region is rich in natural and cultural attractions such as the ancient volcano and coffee plantation that produce some of the best coffee in Indonesia, especially Banyuwangi Gandrung dan culture. We invite you to spend some time during your stay here enjoying the warm hospitality of our people as well as the beauty of our landscape. The geographic condition of Banyuwangi, 5,782.5 square kilometers, equivalent to the area of the island of Bali, or 6 district of Ngawi, Magetan, Madiun, Ponorogo, Pacitan, and Madiun City, East Java Province. The distance between Jakarta and Banyuwangi is 21 hours, and Surabaya Banyuwangi is 7 up to 8 hours. Therefore, the Banyuwangi government priorities transportation access to be cut to 90 minutes from Jakarta to Banyuwangi and 5 minutes from Surabaya to Banyuwangi. And that access is via aviation transportation. The keyword for community service are fast, easy, quality, which can only be achieved through the use of digital technology. With the distance from end of Banyuwangi Regency being between 2 hours to Banyuwangi City, the service must be based on digital technology. The Regency government continues to improve digital technology-based community service. Public service mall, which serve 233 service in one store without having to go to office, which can take too much time. Even through the smart village application, digital application, people can take care of service and permit the village office without having to go to Banyuwangi City. In short, almost all community service are digital-based, whether education, agriculture, transportation, employment, population administration, licensing service are carried out quickly, easily, and with quality by utilizing the synergy and integration of digital technology. So, the International Conference of Artificial Intelligence, Navigation, Engineering and Aviation Technology Seminar by theme Aviation Technology Revolution through Multimodal Integration Innovation is in line, once again, in line with the Banyuwangi Regency government service policy. Have a good seminar. Hopefully, it will increase our insight into aviation service based on digital technology and artificial intelligence. I wish everyone a productive and enjoyable conference. Let the sharing of knowledge and insight begin as we collaborate to create techniques advance for the future. I am sure that through this seminar, there will be increased insight and automation of AI, artificial intelligence, based flight performance, including sharpening, navigation, aircraft maintenance, route application, fuel efficiency, predicate maintenance, air traffic control, and virtual pilot training. Once again, enjoy following the seminar until the end. Thank you. Acah Ibu Fistiandani Aswar Anas, region of Banyuwangi. That is all, and thank you very much.
Okay, give a big applause for Mr. Duyanto, and to Mr. Duyanto, please remain on the podium for a while, sir. And we also like to invite the Honorable Mr. Ahmad Setio Prabowo and Captain Daniel Dewantara Rumani to open this conference symbolically. To the Honorable, please proceed to the stage. Thank you. To Mr. Ahmad Setio Prabowo, after I count to 1, you may touch the button on the screen. Thank you, sir.
3, 2, 1. Let's give a big round of applause for the opening of this
will be representing the head of Ministry of Transportation, Human Resource Development Board. To Mr. Ahmad Setio, you may proceed. Thank you.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, healthy and happy greetings, of course. First of all, let's express our gratitude for the presence of Allah Subhanahu wa Ta'ala, who has given the gift of health and to all of us. The Honorable Region of Banyuwangi District, or representative by Bapak Wianto, Assistant for Economics and Development, the Honorable Professor Dr. Insinyur Aisyah Indah Palupi, MPD, the Honorable Professor Hendra Hermawan, PhD, the Honorable Mr. Josephat Tetuko Sri Sumantio, PhD, the Honorable Professor Insinyur Jainal Arifin Asibuan, PhD, the Honorable Prof. Said Ahmad, PhD, and the Honorable Rector of Bakti Indonesia University, and the Honorable Director of Indonesian Pilot Academy, Mr. Captain Daniel Rumani. And today, happy birthday for him. Ladies and gentlemen, distinguished guests, esteemed participants of the National Conference of Artificial Intelligence, Navigation, Engineering, and Aviation Technology, Icaneat 2023. It is with great honor and enthusiasm that I stand before you today as the keynote speaker, addressing the theme, Aviation Technology, Revolution through Multimoda Integration Innovation. As we gather here at Icaneat 2023, a conference that brings together the brightest minds and in the fields of artificial intelligence, navigation, engineering, and aviation technology. It is an opportune moment to explore the transformative potential of multimodal integration in revolutionizing the aviation industry. Previously, we apologize because the person who provided the keynote speaker should have been the acting head of the Transportation Human Resource Development Agency, Bapak Dr. Captain Wisnu Handoko, MSc. However, because he was unable to attend due to other duties, I had the honor to read his keynote speaker in front of all the audience. Ladies and gentlemen, the slide please. Ladies and gentlemen, distinguished esteemed participants of the International Conference on Artificial Intelligence, Navigation Engineering and Aviation Technology, Icaneat 2023. It is with a great honor and enthusiasm that I stand before you today as keynote speaker addressing by the theme Aviation Technology Resolution through Multimoda Integration Aviation as we gather here at Icaneat 2023. The next please. As an experienced maritime professional, I have seen firsthand how transportation models that were once siloed are now integrating sea, road, rail, ports, and aviation. Through technology, we can connect this in seamless ways. The next, please. Reading the teachings, maritime mobility perceives transformation through sustainability and automation pursuits. MSC Cruise partner fuel cell pioneer Bloom Energy to develop first hydrogen power luxury passenger vessel, shipping major wellness step wind propulsion innovation to design zero-emission autonomous cargo sail ships. The age of swift, smart, and green sea mobility has dawned. Companies integrate automation, alternate propulsion, and decision intelligence to enhance navigational efficiency, boost cargo handling productivity, and pursue decarbonization targets. Seafaring seas, a new avatar, high-capacity autonomous vessel that run on clean energy 24 hours a day, 7 days a week, so shoreside and quayside automation will greatly simplify port stays. Robotic cranes carried cargo in real time into electric baggage and hyperloop networks. Seamless, resilient, and sustainably, sea mobility prime over the coming decade through modernization initiative across the vessels, port infrastructure, and supply chains. Ladies and gentlemen, roadset the transformed through intelligent autonomous truck, platoning together in electric harmony, in right spearheads movement by launching integrated logistics platform combining its self-driving electric tracking network with other transport modes. Our expanded its mobility empire from ride-hailing to aerial ride-sharing through partnership with air taxi startup Joby Aviation. More initiatives underway as share mobility, integrated ground and air transport. Highways to soon make way for efficient road train-style truck platoons. Charging lanes continuously replenish e-truck power needs. Last mile movement minutes by autonomous delivery pods. Orchestrated mobility mass across passenger and freight transport over road and air becomes in mind. Journey planning move from disparate platform to unified interfaces, optimizing trips across ground and rail routes leveraging automation. The next, please. Rail integration future of high-speed transport. Hyperloop and rail set to integrate transforming cargo and passenger mobility. Hamburg Port Authority partners Hyperloop Transportation Technologies to develop Europe's first multimodal cargo solution combining Hyperloop and traditional rail for ultra-fast island port connectivity. Virgin Hyperloop initiates project in India to transport cargo containers directly from seaport to island logistics hub spread hundreds of miles apart via Hyperloop, reducing transit from days to hours. More initiative emerged as Hyperloop and rail integrate. Ports and trains work synergetically former, providing speed over mid-range routes, later ensuring last mile access. Station infra enables seamless port transfer. Ultra-high speed Hyperloop combined with expanded rail transform freight mobility and connectivity from coastal areas into hinterland, optimizing logistics. Passenger travel similarly integrated the modes into the high-speed transportation fabric as a regional connectivity conference. Ladies and gentlemen, port as the future. Port integrates drones, air taxis, and hyperloops transforming into smart multimodal hubs. San Diego Port deploy drones for on-demand maritime delivery, resolving last miles challenge. NWeb partners SEBCA to enable medical drone delivery from port to hospitals. Port infrastructure reinvents with landing lanes allowing air taxi and hyperloop station for rapid evacuation. Command center use all the orchestrate terminal operation, tracks flow and optimize staging, storage and transfers between ship, trucks, ports and drones. Aviation port of future penetrate islands seamlessly via integrated land-side links. Bulk cargo transported real-time after vessel discharge onto waiting hyperloop or electric bigs through automation. Just-in-time manufacturing needs meet by responsive multi-drop drone delivery. Port transformation underway as altitude optimization elevate cargo velocity through terminal onto integrated aerial, terrestrial and subterranean mobility link facilitating frictionless global trade. Next, please. Reshaping urban air mobility. Aviation integrated emerging aerial mobility modes, expanding services. United Airlines invests in air taxi startup AirShare to add intra-city passenger connectivity through vertical takeoff of vehicle. Air New Zealand partners Skyport to enable drone delivery from airport from time-sensitive cargo and medical supplies. More initiative take off as air travel converges with contiguous zones, supplementing fight with hope on eVTOL option. Vertisport get embedded across metro cities, accessed via application for frictionless ride transfer to close proximate destination not viable by ground routes. Smart aviation ecosystems and augmented infrastructure set to redraw passenger and cargo flows across a connected city through integrated aviation layer converging flights, air taxi, and delivery drone tailored and for range and purpose. On-demand aviation envisioned with expanded software defined morphing networks that resemble aerial mobility. Ladies and gentlemen, the next please. Advancement across electrification, autonomy, and connectivity set to reshape mobility fabric, unlocking sustainability and efficiency. Future road network to comprise electric truck route trains streaming seamlessly through logistic grid. Fourth, turnaround accelerate via orchestration between shoreside, automation, and autonomous vessel. Urban air taxi skyports expand as mobility hubs, integrating last mile fly rail connectivity. IoT meshes bin ETL, enabling ununified command via digital twins mirroring vehicle across transport vertical, helping orchestrate system flow through optimization layer. Mobility prepares for a sustained reboot from fragmented to unified, siloed to shared, transactional to experiential. The foundation for the grid of the future get constructed today through vehicle and infrastructure that deserve modal monopolies to redistribute access abundantly. Integration's goal focus on enabling transparent. Next, please. Integration goals focus on enabling transparency, synergy choice, and coordination across transportation ecosystem. End-to-end supply chain visibility over unfied common over multimodal cargo flows. Open share data analytics allows systematic optimization across assets, infrastructure, and flows. Business model reshape around integrated mobility platform, converging operators from aviation, ground transit, and maritime into consolidate journeys, package, and experience. Customer gain more reliability, efficiency, and flexibility through expand route and modal choice to meet different needs. Transportation get reinvented as interconnected system, elevating individual access while attaining public sustainability targets. Recast mobility priorities, people over vehicle, access over ownership, renewability over ecological harm, set the state for mobility to be delivered as an efficient, demand-focused servicing, unlocking a value. The key lies in dissolving modal monopolies into coordinated meshes that balance commercial growth with climate consciousness, delivering maximized social return sustainability. Ladies and gentlemen, emerging aviation frontier signal new capacities in aerial mobility. eVTOLs and air taxis will offer affordable on-demand urban and regional flight connectivity for passengers. Automate flight control and a collision avoidance system will enable safe scaling of increased air traffic density. Cargo drone powered by electric propulsion present low operating costs for short-haul point-to-point delivery, improving supply chain response shiftness. Hyperloop networks will provide high-speed connectivity between urban clusters for rapid passenger and freight transport. Convergent mobility via integrated skyways and hyperloops promise efficient door-to-door delivery across long distance, combining speed, feeder access, and last-mile connectivity, leveraging automation and electrification breakthrough across a model. The future of flight powered by decentralized aviation technologies promise to transform accessibility and cargo capacity over distance while embedding aviation deeper within sustainable mobility solutions. Ladies and gentlemen, electric vehicle takeoff and landing or aircraft or eVTOLs are pioneering innovation in aerial mobility. eVTOLs like those being developed by Joby, Lilium and Volocopter promise quick, affordable air taxi services for urban communities. These electric planes allow passengers to avoid congested roads through short air trips powered by lithium batteries and distributed motors. Drones are finding extensive application for last mile delivery service given flexibility, safety, and cost economics, especially for urgent shipments. Logistic companies like Zipline, Meternet, and makers like Boeing leverage drones for medical supplies delivery and enabling faster shore-to-ship or port-to-destination cargo movement, circumventing routes. Decarbonized aviation technologies promise an accessible air transport layer integrated into future smart cities and supply chains through elevated mobility skyways for people movement and aerial delivery corridors for logistics tailored for range and need. Urban air mobility powered by electric aerial riding sharing vehicle will provide affordable on-demand connectivity for city travelers to avoid congested routes. Airbus, Embraer, Bell, and startup who showcase prototypes anticipated to launch intra-city share air taxi service in coming years. NASA and Boeing are paving development of autonomous flight management system for precision navigation, takeoff and landings leveraging AI, machine learning, and sensor fusion. The tech allows self-floating and promise to enable future scaled development of flying taxi fleets and delivery drones with beyond visual line of sight operation without human pilots. Regulation aimed to make more airspace accessible. Vertiports with integrated landing infrastructure and charging station get enabled across cities. Air traffic control upgrades to manage drone and flying vehicle stacked at a different altitude. Using in technology and infrastructure to realize smart city skies that layer urban mobility through safe, sustainable, accessible, and affordable on-demand flight service. Ladies and gentlemen, the wide range of aviation innovation from electric flight to cargo drone herald tremendous potential benefiting future urban mobility across three key dimensions. Faster intracity land and last mile connectivity, eVTOLs, and flying taxis with over rapid point-to-point rides within cities, reducing travel times significantly and avoiding route congestion. For logistic drones provide last mile responsiveness for on-demand delivery services. Reduce conjunctions on road, like enabling reliable and affordable aerial mobility takes load of congested urban roads, allowing focus on mass public transit system. Environmental footprint also reduced with electric aviation and advancing. Door to destination passenger routes, like integrating takeoff vertiports within metro transit network, creates expanded access to destination not directly connected by flight alone early. The transformative technologies pave way for inclusive, minimally invasive aerial connectivity for passengers and cargo, placing aviation technologies as catalyst for sustainable and efficient future smart city. Ladies and gentlemen, the future of transportation promises to integrate various modes into unfied journeys for passengers and cargo, leveraging specific capabilities. Air taxi over rapid airport transfer to Hyperloop station for medium range high-speed connectivity, followed by last mile on-demand ports. Port embed drone infrastructure, allowing offshore ships to transfer containers to low-footprint aerial vehicle, circumventing routes to reach island destination faster through dedicated sky routes. Travel involved to privilege access abundance through flexible mobility blends rather than vehicle ownership alone. Journeys converge aviation with advanced rapid rail and autonomous shuttle layers according to context need with ease of modal shift. Mixed mobility traverses closer to the ideal the transport on demand. Aviation plays a pivotal role steering rapid aerial connectivity into trips, augmenting high-speed rails, hyperloops, and autonomous shuttle to destination. More fictionless points in human stories. Air taxis and hyperloops integrated to provide door-to-door connectivity, leveraging base of speed and access. Air taxis offer airport transfer, circumventing routes, while hyperloops enable medium-range, high-speed point-to-point links. Share mobility hubs corporate both modes. Lilium Virgin Hyperloop One and Hyundai spearhead developments. Use case like LA to San Francisco highlight the power of modal synergies. Air taxi from origin to LA airport, followed by ultra-fast hyperloop connectivity to San Francisco station, and last mile air taxi commuting again to reach destination, avoiding traffic. Many more such combinations get unlocked to more mobility from soil networks into converged transportation meshes, allowing different modes to complement strength on demand need for passengers and cargo. The future beckons faster multimodal journeys, converging hyper aviation technologies like eVTOLs and hyperloops through common integration infrastructure for maximum aviation. Cargo drone unlock new aerial shipping lanes for last mile port delivery by leveraging speed, flexibility, and sustainability benefits. Drones avoid route bottlenecks through dedicated sky routes, either for on-demand urgent shipments. Logistic companies like Wilco,
altitude angel and skyports geared up drone delivery infrastructure. Use case span vessel translating container to drones offshore, circumventing ports to directly deliver cargo to coastal warehouse at destination through this low footprint electrical vehicle. More scenario, operational as battery, automation and traffic management technologies, method to scale drone delivery layers, port reorient around multimodal cargo transfer infrastructure, ships, integrated landing pads in design, command center orchestrate logistic dynamically rerouting between ground and air capacity as per urgency, weather, and demand. The future beckons integrated delivery ecosystem optimized around cargo urgency, sustainability, and efficiency parameters beyond just cost. Drones promise to profit the sky rail advantage to freight movement, unlocking responsiveness. Ladies and gentlemen, multimodal transportation promise salient benefit ranging from enhanced connectivity, reduced infrastructure dependency, and enabling urgent deliveries through synergies. Faster intercity and last mile journeys get unlocked by converging hyperloop, electric aviation, and autonomous pods tailored by segment needs. Travel accelerates science fiction. Logistics achieves responsiveness and sustainability via drones circumventing route for urgent critical achievement delivery. Optimized integration allow harnessing situational capability and patterns across mode while offsetting individual limitation through complementing networks. Aviation provides rapid long-haul mobility. Hyperloop enable medium-range high-speed transit. Electrical pods manage last-mile movement, orchestrated for end-to-end fluidity. Joint delivery unlock grid connectivity. Decongestion and carbon efficiency across integrated transit option perspective over standalone networks. The collective system outperform the sum of individual vehicles, pointing to a congestion-free, accessible, renewable future of mobility. Ladies and gentlemen, the convergence of aviation with surface and subterranean transport network heralds a mobility revolution. Aviation tightly integrated with roads, hyperloop, and shipping infrastructure into unified ecosystem exchanging data, traffic, and loads. Integration becomes viable through the proliferation of sensor, IoT, automation, and AI across individual models, allowing orchestrated interactions, movement tracking, and flow optimization holistically. Its constituent mode contributes an unique advantage into the system. Aviation provides a real rapid mobility. Hyperloop enable medium-range high-speed transit. Electric pods manage last-mile mobility. Different modes augment capabilities based on purpose and situational context. As aviation innovates with eVTOLs, drones, air taxi, it cases to remain an isolated mobility vertical but transform into an augmented blended mobility system networked with other modes moving people moving people and goods boundlessly. The true mobility revolution arises from dissolving modals monopolized into polymorphic integrated transportation that gears focus on maximizing flexibility, sustainability, and access abundantly. The aviation industry is rapidly transforming from an isolated soil network into an interconnected one. Airlines increasingly involve hub into multimodal zone with seamless connectivity to trains, buses, and autonomous pods. Strategic partnership get forged across the transport spectrum to enable integrated flows. This convergence become viable through the swift proliferation of sensors, IoT connectivity, automation, and artificial intelligence across mobility network. IoT allows the real-time locating, tracking, and coordination of traffic movement. AI and predictive analysis optimize and unified transportation workflows holistically. Automation and robotics execute processes lacking human supervision across infrastructure like ports and delivery. The technological advance make it visible to dissolve modal silos, ensure interoperability through open interface, and collectively manage mobility via smart coordination layers. Airline integrate itinerary across ground and air routes, port embedded infrastructure for drones and air taxis integrated. Mobility fabric gets continuously woven. Ladies and gentlemen, integrated mobility allows selectively harnessing situational advantage of its transport mode and offsetting limitation through network effect. Aviation provides rapid aerial mobility over long distance while being capacity constrained. Ground transit penetrates congested cities with accessibility and flexibility. Shipping handles heavy freight volumes over water bodies cost effectively. Jointly, the integrated system scale capacity enhance reliability and resilience to disruption and over unified seamless journeys with expand rich choices. User gain more efficiency, option, and transparency. In effect, the collective transportation output exceeds the sum of individual modal capabilities, pointing to a future of congestion-free, accessible, renewable mobility with its leveraged appropriately based on context and need. Ladies and gentlemen, to summarize, the convergence of breakthrough innovation across transportation spheres ranging from electrified aviation, autonomous driving, AI-based traffic optimization to drones and hyperloops, users in reality of integrated mobility ecosystem soon. What we construct as isolated modal networks tend to dissolve into platform facilitating multidimensional movement, aerial, ground, subterranean becoming continuous channels varying people and freight based on a purpose, urgency, and sustainability consideration seamlessly. The sum of outcomes from the unfight system of outweighing individual modal capacities point to a future beyond traffic congestion, carbon constraint, and access limitation. As aviation transform for a soil vertical into an augmented network interwoven across complementary modes like advanced rail and shuttle alternatives. It paved the way for a grid of integrated mobility that promises to accelerate human progress through enhanced connectivity, time restoration, and responsible development. I call upon the innovators greater here to collectively work towards democratizing access to proficient mobility for the world by investing in technologies rooted in shared objective of sustainability, reliability, and positive impact besides commercial success alone. Our integrated future awaits manifestation. Our integrated future awaits manifestation. I appreciate that opportunity to present this few points which draw on my naval experiences while looking at aviation developments. To move this discourse ahead, I welcome your comments and perspective. And thank you for your appreciation and enthusiasm for the participants who attended today. Hopefully, this will broaden our scientific knowledge in aviation technology, and we would like to express our thanks to all speakers, reviewers, and community members involved in carrying out this conference to maintain academic enthusiasm to improve the quality of aviation induction in Indonesia. Thank you very much. Our gratitude, Dr. Captain Wisnu Handoko, MSc. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Ahmad Setio Prabowo, for the amazing insights, and please remain in front of the podium. And now we would like to invite Captain Daniel Dewantara Rumani and Mr. Dwi Yanto for the handover of certificate and plaque from Indonesia Civil Pilot Academy of Banyuwangi.
The first certificate will be given to Mr. Ahmad Setio Prabowo as keynote speaker for today's conference. Okay, and the next certificate and plaque will be given to Mr. Dwi Yanto as the representative of the region of Banyuwangi. Okay, give a big applause. Now for the photo session. And the next pose, commando pose. Okay, thank you to Mr. Ahmad Setio, Mr. Duyanto, and Captain Daniel Dewantoro. You may return to your seat. Thank you. Ladies and gentlemen, on this next session, let us watch the campus profile of Indonesian Civil Pilot Academy of Banyuwangi.
Banyuwangi merupakan salah satu sekolah pilot atau lembaga diklat yang berada di bawah Kementerian Perhubungan. Tapi Banyuwangi juga merupakan member dari IQ Train Air Plus, dan saat ini atas dukungan Kementerian Perhubungan melalui Badan Pengembangan SDM Perhubungan, Akademi Penerbang Indonesia Banyuwangi telah menjadi sekolah pilot pertama di Indonesia yang mencetak pilot dengan rating C-Land. Banyuwangi memiliki fasilitas akademik dan non-akademik yang modern dan terawat. Fasilitas ini terus kami kembangkan untuk menunjang pendidikan dan pelatihan untuk mewujudkan visi kami, yaitu terwujudnya sumber daya manusia penerbang yang prima, profesional, berkarakter, dan berdaya saing tinggi. Saat ini, API Banyuwangi memiliki program studi sebagai berikut. Diploma 3 Penerbang Sayap Tetap, Diploma 3 Operasi Pesawat Udara, Non-Diploma Penerbang Sayap Tetap, diklat teknis lainnya, serta program sipil yang pengoperasiannya telah diresmikan oleh pelaksana tugas Kepala Badan Pengembangan Sumber Daya Manusia Perhubungan dan juga Bupati Banyuwangi pada 18 Oktober 2021.
Mengikuti perkembangan teknologi transportasi saat ini, API Banyuwangi telah menambah capability list C-Plan pada program penerbang sayap tetap. Dengan adanya capabilities ini, lulusan API Banyuwangi turut berperan serta mencetak perwira penerbang dan flight instructor single engine C class rating. Sejauh ini API Banyuwangi telah menjalin kerjasama dengan pihak terkait untuk terus meningkatkan kualitas serta layanan kami. Kerjasama tersebut terus kami tingkatkan dengan lembaga diklat dan operator pesawat udara dalam dan luar negeri. Kami pun terus berupaya menghasilkan lulusan daya saing yang siap bekerja pada industri penerbangan baik secara nasional maupun internasional. Dan kami membuka seluas-luasnya bagi generasi muda untuk bergabung bersama kami dan menjadi penerbang andal dan profesional.
Lulusan Diploma 3 Penerbang Sayap Tetap akan mendapatkan Private Pilot License, Commercial Pilot License, Instrument Rating, dan Multi-Engine Rating. Untuk lulusan Diploma 3 Operasi Pesawat Udara akan mendapatkan Flight Operation Officer License, Aircraft Movement Control License, Dangerous Goods, Marshalling License, dan Basic Aviation Security License. Sedangkan non-diploma penerbang sayap tetap akan mendapatkan Private Pilot License, Commercial Pilot License, Instrument Rating, dan Multi-Engine Rating. Tapi Banyuwangi memiliki 37 armada pesawat latih dari pabrikan Cessna dan Beechcraft dari United States of America yang terdiri dari pesawat latih sayap tetap multi-engine Piper PA-34 Seneca V-Loading bertenaga 440 horsepower dengan kapasitas 4 penumpang. Kemudian pesawat latih sayap tetap single engine Cessna 172 Skyhawk SP high wing 180 horsepower dengan kapasitas 2 penumpang. Pesawat Cessna 172 Skyhawk Special Performance yang telah dimodifikasi menjadi seaplane dengan penambahan amphibian float kit. Sebelum terbang, Taruna dan Taruni wajib menguasai pesawat melalui simulator yang serupa dengan pesawat latih, yaitu Red Dot Simulator FMX Full Promotion, Alsim 172, dan Alsim 250. Lingkungan kampus API Banyuwangi ditata asri, rapi, bersih, dan menyenangkan dengan fasilitas olahraga yang menunjang kesehatan bagi para taruna dan taruni. Pola pendidikan dan pelatihan di API Banyuwangi menerapkan pola disiplin around the clock.
Indonesian Civil Pilot Academy Banyuwangi. Ladies and gentlemen, now we will begin our main session. In today's conference, there will be 5 honorable and amazing speakers who have lined up and ready to share their wonderful insights. First, we will be led by Mr. Ahmad Bahrawi as the moderator for today's event. To Mr. Ahmad Bahrawi, time and place is yours. Thank you. Supporting us on this very amazing event is the co-host from Politeknik Penerbangan Indonesia Curug, Institut Teknologi Civil Universitas Surabaya, and also Universitas Pembangunan Pancabudi Medan. Okay, to Mr. Ahmad Bahrawi, time and place is yours. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, very good morning to all of you. Okay. Please introduce. I want to introduce myself first. My name is Ahmad Bahrawi. Currently as the head of education division in Air Transport Human Resources Development Center atau sebagai kepala bidang pendidikan di Pusat Pengembangan SDM Perhubungan Udara. It is an honor for me to be here today as your moderator for the seminar with the theme of Aviation Technology Revolution through Multimodal Integration and Innovation. As we gather here today, we are reminded of the importance of collaboration and innovation in shaping the future of technology. With the rapid pace of technological development, it is crucial that we continue to explore new ideas and approaches to address the challenges and opportunities that lie ahead. I am confident that this conference will provide a platform for fruitful discussion and meaningful exchanges of ideas. So I encourage you all to take advantages of this opportunity to learn from one another and to forge new partnership and collaborations. This conference brings together experts and professionals from various fields to share their knowledge and insight on the latest advancement in this area. So we have five distinguished speakers today, and our first speaker is Professor Dr. Insinyur Aisyah Endah Palupi, MPD. Good morning, Prof.
Good morning.
Assalamualaikum. Can you hear my voice?
So clearly, man. Yeah.
Okay. Soundnya. So yeah. I can see that you can hear us, but we cannot hear your voice yet.
Hello, tes.
Okay, bisa digedein sebentar dikit, Mas? Okay.
Thank you, Pak Ahmad Barawi.
Ya, apa kabar Ibu di Manila?
Alhamdulillah sehat.
Alhamdulillah. Okay, Prof. Dr. Insinyur Aisyah Endah Palupi, MPD, is a renowned expert in the field of chemical engineering. She currently serves as the Education and Culture Attaché at the Embassy of the Republic of Indonesia in Philippines. With a strong academic background, including a doctoral degree and master in education, Prof. Aisyah has been actively involved in research and education. Her expertise in areas such as ultrafiltration, membranes, and citizenship education has been widely recognized. She has also contributed to the conference and publications, demonstrating her commitment to knowledge dissemination and academics excellence. So, ladies and gentlemen, please welcome Professor Dr. Insinyur Aisyah Endah Palupi, MPD.
Thank you. Thank you, Pak Ahmad Barawi, as a moderator. Please allow me to prepare for my presentation. Yes. Before that, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning everyone. Magandang umaga sa inyong lahat. Honorable Dr. Kapten Wisnu Handoko, MSc, as the Head Authority Port of Tanjung Priok and Head of Human Resource Development and Transportation Agency, and Kapten Daniel Dewantoro as the Director of Indonesia Civil Pilot Banyuwangi. Apa kabar Bapak? Even though we meet again through online, like a youth reunion today, semoga Bapak sehat selalu. And then for the all keynote speakers and beloved all participants in this event, thank you for this opportunity. I can say sharing. I'm a Education and Culture Attaché in Manila. Today, I would like to informations about the aviation education, especially in the Manila. In the first slide, before this, to start my presentation, I would like to ask everyone, why choose aviation? What makes you decide and convince yourself that you want to learn about aviation? But whatever your answer is, I want to keep that in mind until the end of my presentation. And for this, aviation in the Philippines play a crucial role in connecting the archipelagos islands and facilitating both domestic and international travel. The country has a dynamic aviation sector with various airlines, airports, training institutions, and regulatory bodies. Here are a key aspect of aviation in the Philippines. One is for the airlines. The Philippines is a home to several airlines, both full service and low-cost carriers. Philippine Airlines, like PAL, Philippine Airlines, is the flag carrier and the oldest operating airlines in Asia. Other major carriers include Cebu Pacific and Air Asia Philippines. Others is Air Force. In the Philippines, have multiple internal and domestic airports. Nino Aquino International Airport, Naya, in Manila, is the primary international gateway, while other major airports include Mactan Cebu International Airport, Clark International Airport, and Davao International Airport. Uh, the other of the information is about the training institution, which is various institution in the Philippines offer aviation related education and training programs. These include universities, colleges, and special aviation training centers providing courses in aeronautical engineering, aviation management, pilot training, and aircraft maintenance. And talking about the regulatory authority, in the Philippines, we have the CAAP, the Civil Aviation Authority in the Philippines. There is the government agent responsible for regulating civil aviation in the country. CAAP oversees safety, security, and compliance with international aviation standards. And about the infrastructure development, in the Philippines has ongoing initiatives to enhance airport infrastructure and accommodate the growing demand for air travel. Projects include airport expansions, upgrades, and the development of new airports. And talking about the international air connections, the Philippines maintains a strong international air connections, serving as a hub for flights to and from various countries. These connections contribute to the country's economic growth and tourism industry. And others is about tourism impact. There is aviation in the key driver of the tourism industry in the Philippines. The country's beautiful bases, cultural attractions, and natural wonders attract millions of tourists each year, and air travel is vital for their transportation. And the challenges in the aviation industry in the Philippines faces challenges including infrastructure constraints, airspace congestion, and the need for continuous improvements in safety and regulatory oversight. We are talking about the aviation education in the Philippines is offered by various institutions, including universities, flight schools, and training centers. Here in the slide, I would like to explain some key that we need to consider to choose aviation school or education. Then we can see about the universities and colleges. Some universities and colleges in the Philippines offer degree programs related to aviation, such as Bachelor of Science in Aeronautical Engineering or Aviation Management. This program typically covers various aspects of aviation, including engineering, management, and aviation safety. And the second one is a flight school. Several flight schools in the Philippines provide pilot training programs. These programs range from private pilot licenses to commercial pilot license. Flight schools often have partnerships with aviation authorities to ensure that their training programs meet the necessary regulatory standards. And we are talking about the aviation training centers. Besides universities and flight schools, there are specialized aviation training centers that offer courses in the aviation maintenance, air traffic control, and other aviation-related fields. This training center may provide certification and license required for specific rules within the aviation industry. And talking about the regulatory compliance, it is crucial to ensure that any aviation education program or training course you choose is recognized and approved by the Civil Aviation Authority of the Philippines, CAAP. CAAP is the National Aviation Authority that which is responsible for regulating civil aviation in the country. And talking about the industry partnerships, some institutions may have partnerships with aviation industry stakeholders, such as airlines and aviation companies. These partnerships can provide a student with opportunities for internships, on the job training, and potential employment after graduation. And about the financial considerations, pursuing aviation education can be a significant financial investment. Students should consider tuition fees, flight training costs, and other related expenses. Additionally, they may explore scholarships opportunities or financial aid programs. And the last but not least about the aviation education is about the career opportunities. The Philippines has a growing aviation in industry, and there are various career opportunities for individuals with aviation education, including pilots, aircraft maintenance engineering, aviation managers, air traffic controllers, and more. Talking about the vocational education in the aviation in the Philippines, vocational in the Philippines is typically geared toward provide practical skills and hands-on training for support for specific roles within the aviation industry. Here are some common courses in the aviation offered in the Philippines. There is the aircraft maintenance technology, aviation electronics and avionics technology, air traffic control training, flight attendant training, etc. And the advantage of the vocational education, which is the focus of practical training, shorter durations, cost-effective, industry-relevant skills, high demand for skilled workers, certifications and license, career progressions opportunities, practical experience in real-world setting, diverse career options, and industry connections and networking. It's the Philippines several aviation schools in the Philippines offering training programs in various aspects in the aviation, like Philippine STA, States College of Aeronautics, is a government institution that offers aeronautical education. They provide programs in aeronautical engineering, aircraft maintenance, avionics technology, and air transportation. And we also, the Philippines also have the WCC, Aeronautical and Technical College. Captain Daniel is already to meet a delegate from the representative from the WCC. Actually, we have the planning go to Banyuwangi, but Captain Daniel is joining with us in Jakarta on that time. And located WCC in Philippines is Binalonan, Pangasinan. WCC Aeronautical and Technical College offers courses in aircraft maintenance technology, avionics technology, and aeronautical engineering. And about the Airling International Aviation College, has a campuses in Pasay City and Clark Freeport Zone. They offer courses such as aircraft maintenance technology, avionics technology, and aeronautical engineering. And about the aviation technology innovators in company, ATI provides courses in aviation maintenance technology, avionics technology, and airframe and power plant mechanics. They are based in the Pasay City, in the same place with the WCC. And the PATPS, College of Aeronautics, located in Paranggi City, offers program in aeronautical engineering, aircraft maintenance technology, avionics technology, and air transportation. And Maksan Aviation Technology School, MRTS, is situated in the Lapu-Lapu City, Cebu, Cebu. I think Captain Daniel is many times go to Cebu because on there is a very beautiful beach. Yeah. MEPS is offer courses in aircraft maintenance technology, avionics technology, and air transportation. Is Omni Aviation Corporation is provide aviation related courses including private and commercial pilot training, cabin crew training, and aircraft maintenance courses. They are based in the Clark Freeport zone. And the last is the Philippine Airlines Aviation School, PALAS. PALAS is offer courses training aircraft maintenance and avionics technology. Here is just for short information about the Philippine education. As many, and that's the same level with our ministry, but in the Philippines can be to part each of the education level have the ministry, like ECCD councils is about the health, nutrition, early education, and social services for children aged 0 until 4 years, and the Department of Education, Step F, and then the Ministry of about to responsible for the vocational is a TESDA, and for the higher education the ministry is a Commission Higher of Education or CHED. And about the vocational education in the Philippines, also known as technical and vocational education and training, TVET, plays a crucial role in the country's educational system. And talking about the program of the for each like structure of a TVET programs in the Philippines offer at different levels, including secondary, post-secondary, and tertiary levels. They are typical delivered through technical vocational institutions, TVIs, both public and private, as well as through some universities and colleges. The implementation of K-12 program in the 2013 expanded the vocational education system by incorporating technical vocational livelihood (TVL) track in seniors high school. This allows students to choose special vocational subjects related to their career interests, such as automotive, electronics, agriculture, culinary arts, and more. And the TVET program leads to the acquisitions of national certificates, NCIs, issued by the Technical Education and Skill Development Authority, TESDA. These certificates serve as proof that individuals possess the competencies required for specific occupations. Higher level programs can also lead to the awarding and diplomas. And talking about the TESDA, it's a government agency responsible for overseeing and regulating TVET programs in the Philippines. TESDA develops competency-based training standards, conduct skills assessments, and provide scholarships and training subsidies. About the public-private partnerships in the enhanced TFET, many private institutions collaborate with TESDA to offer relevant and industry-aligned training programs. This ensures that TFET programs are responsive to the needs of the job market and promote employability. And about the Philippines also implements a dual training system they call GPS that combine in-school education and on-the-job training. This approach allows students to gain practical experience in the real work setting, improving their readiness for employment. And the TFET program in the Philippines often collaborate with industry to align their curricula with the demands of the labor market. These partnerships facilitate internships, apprenticeships, and job placements, increasing the chances of employment for graduates. Recognizing the significance of the overseas employment, TFET program offers specialist courses to equip these individuals with skills highly sought after abroad, and this program addresses specific skills required in the industry, such as healthcare, construction, hospitality, and shipbuilding. This is talking about the TESDA. TESDA is an offer. It's very variety of the technical vocational courses, including related of aviation. TESDA aims to provide skill training development program, like I mentioned before. And here are some TESDA courses related for the aircraft maintenance technology, avionics installations and maintenance, aeronautical engineering technology, airport ground operating, and private pilot course, airline services. But on the last night, I already to check right now only on the test that is offering only aircraft maintenance technology. The last information about the Philippines bilateral cooperations for aviation schools. That's an example, that's a collaborations between the WCC with Akademi Penerbangan Indonesia Banyuwangi and Politeknik Penerbangan Indonesia in Curug. I go on there and so warm, I accepted, so warm welcome. Which is the collaborations with the aviation sector is with the WCC and API Banyuwangi and Politeknik Penerbangan Indonesia in Curug. And then the memorandum of MOU reflecting the consensus resulting from mutual understandings between the leaders of these institutions. Scope of the cooperation is example is faculty and staff exchange, student exchange, immersion and apparent ties and etc. Until now, I'm waiting the implementations of the collaborations, sir. And 20 January in this year, this is a signing. This is me. And then Captain Daniel, and then the director of the API Politeknik Penerbangan in Curug. Yeah. And when we in the Jakarta, we introducing WCC to SMPK Penabur International School Tanjung Duren too. And this is our social media. Thank you. Thank you so much. Maraming salamat po sa inyong lahat. Back to Mas Moderator.
Terima kasih Prof atas penyampaian yang luar biasa. Thank you very much for the information. I believe that the information that you share with us about the aviation training and education system in Philippines will be give more information for us about how the training is conducted in Philippines. Once again, terima kasih banyak Ibu for sharing your time. I believe they are very busy. So we give applause to our first speaker, Professor Dr. Insinyur Aisyah Endah Palupi. Thank you, Bu. Sign, take off sign. Thank you, Ibu.
Thank you. Ya, oke.
Terima kasih, Ibu. Selamat bertugas kembali.
Sama-sama, Mas Moderator. Kami akhiri. Mohon maaf apabila kami tidak bisa mendampingi sampai Q&A. Semoga sukses acara ini. Wabila taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih, Ibu.
Silakan.
Baik, Bapak Ibu semua, ladies and gentlemen, this is the first presentation of today from Professor Dr. Insinyur Aisyah Endah Palupi MPD. And for the next speaker, we will have Professor Hendra Hermawan PhD. Okay. Good morning, Prof. Hendra, or good night for you at Canada. Selamat malam, Bapak.
Yeah, good afternoon actually.
Oh, good afternoon.
Because I'm currently in Melbourne, Australia.
Oh, okay. You are in Melbourne. Sorry, I thought that you were in Canada. Okay, Dr. Hendra Hermawan, an esteemed expert in his field. Dr. Hermawan holds a PhD and is a professional engineer. He has made significant contribution to the field of the material engineering. And we are honored to have him to share his knowledge and insight with us. So please join me in welcoming Dr. Hendra Hermawan. And for your information, Dr. Hendra, we are here gathered in API Banyuwangi and also through online platform, Zoom platform. There are about 34 participants with us, but I believe mostly with us speak bahasa more fluent than English. So if you want to deliver in bahasa, and I believe because the material that you will deliver will be fruitful for us and will give more information. I think in bahasa will be better for us. So please, Dr. Hendra.
Okay, thank you very much, Mr. Ahmad Bahrawi. Good afternoon, everyone. Unfortunately, I already said my presentation in English, so I cannot just change and switch to bahasa quickly. So I will continue my presentation in English, but it will be easy in English. So thank you very much for giving me the honor to present a talk in this highly regarded conference in aviation. My name is Hendra Hermawan, an associate professor in materials engineering at Laval University in Canada. So however, after flying half of the world, I'm now sitting in the office of my colleague at the Swinburne University of Technology in Melbourne, Australia. And I will be flying back to Canada next week, following this route. So since I was a little boy playing with kites, I have been passionate about aviation. Aviation has been progressing so fast in the last 100 years, from a mere 250-meter flight distance by the Wright brothers in 1903 to 11,000 kilometers in a single Boeing 787 flight from Vancouver to Auckland that I just did yesterday, from using wood and fabric to using titanium and carbon fiber composite, from carrying only 2 people to carrying more than 600 passengers and cargo. But despite all this technological progress, there is always a lingering problem in aviation, the aircraft corrosion, which will be the topic of my talk. And There is no other airplane that fascinates me the most but this 285-ton Airbus A380. 60% by weight of this structure is made of aluminum alloys. Indeed, aluminum has been the flying metal, the most used metal in aviation, and it is for three main reasons. First, strength. An aluminum alloy type 7T75 T6 can reach a tensile strength of more than 500 megapascal, as high as that of some steels. Second reason, lightweight. At that strength, the alloy has a density of only 1/3 of that of steel. The third reason, corrosion resistant. Thanks to its naturally formed passive film, aluminum resists corrosion and can be improved further by anodizing process. Let's briefly see how aluminum alloys are made. Basically, it involves three stages. First, Bayer process that transform aluminum ore, the bauxite, into alumina using hydro and pyrometallurgical steps. Second, the Hall-Héroult process that extracts aluminum from alumina using electrolysis method. And the third is alloying process that mix pure aluminum with alloying elements according to the standard specification. So thanks to the alloying process, pure aluminum that was relatively soft turned into strong alloys such as the type 2024, an alloy of aluminum with copper, and the type 7075, an alloy of aluminum with zinc. This huge increase in strength, as you can see from this curve, was achieved through precipitation hardening mechanism. For 7075 T6, it involved solution treatment where the metal is heated to 470 degrees Celsius, followed by cold water quenching and aging treatment, where the metal is heated to where the metal is subsequently heated to 120 degrees Celsius for 10 hours to allow precipitation of aluminum zinc microparticles. Achieving high strength must not compromise corrosion resistance. Since microstructure determines both strength and corrosion resistance, the heat treatment process, like the precipitation hardening, must be optimized. In a recent work with my colleague at the University of Indonesia, we achieved the optimum benefit of strengthening precipitates in providing high strength without sacrificing the corrosion resistance of aluminum alloy 7075. We determined that higher corrosion resistance was achieved on the specimen annealed at 500 degrees Celsius as the result of copper enrichment in the solid solution matrix. Now, I would like to show you why aluminum alloys become the materials of choice. Okay? Let us focus on this simplified loading condition of an airplane wing. It is subjected to tension during ground maneuver due to the fuel weight, to compression during straight and level flights due to lift. And despite the wing's complex structure, let us assume the shape of wing skin as a simple flat plate. Okay, so under tension, maximum load is limited by the ultimate stress of materials, as shown by this formula. F maximum equal to tensile strength multiplied by its area, which is thickness T times width B. Then by considering the weight of the plate and a simple mathematical manipulation, we found that the higher the ratio of tensile strength to density, the more efficient its tensile strength. The same principle applies to an under compression condition. After a simple mathematical manipulation, we found that the higher the ratio of root elastic modulus or Young modulus to density, the more efficient is buckling stress. So these two formulas are called the materials performance index to be used as the material selection criteria for wing skin. So by using the criteria and this available that material data for 4 different materials, we can make calculation, ranking, and selection of the optimum materials. From the first table, we can see that steel is the strongest. But after calculating its performance index, we see steel has the worst index of tensile strength, tensile fracture, and plate buckling, but it is the cheapest. Composite has the best index, but it is the most expensive. This leaves us to 2 choices, aluminum and titanium. In terms of plate buckling, aluminum is better, okay, than titanium. And in terms of tensile fracture, the difference is not significant. But in terms of cost index, aluminum is much more economical than titanium. So that's why aluminum is not only mechanically performed, but also cost effective. That's why aluminum is always the materials of choice. So now we understand why we use more aluminum, like 61% for Airbus A380. Other metals used in aviation are titanium and superalloys. These are extraordinary alloys that made the jet engine possible to make. Remember, even though the concept of jet engine was introduced before World War II, only in the 1960s we can make it into service, thanks to the discovery of these superalloys, among others. And the materials that makes aviation more and more efficient are composite. As we can observe, the engine diameter of an A320 Neo is much bigger than its predecessor. The bigger diameter of the fan, the higher the bypass ratio we can achieve. But increasing the fan blade radius, okay, let's see by this equation, will increase centrifugal force. Thus, lighter yet strong material must be used, and the answer is the carbon fiber composite. Aviation has been the safest mode of transportation due to its safety stringent regulation, the stringent safety regulation. But incidents sometimes happen. Historically, we recall the corrosion-related incident of Aloha Boeing 737, which was flying from Honolulu to Hilo in 1988. An NTSB investigation report released in 1989 linked the incident to the failure of operator's maintenance program to detect corrosion damage. The investigation showed that the corrosion accelerated fatigue of the fuselage skin panels was the failure mechanism. Another similar aircraft inspection revealed problems with peeling, corrosion, and cracking at the panel joints. So the corrosion process and the accumulation of expanded corrosion product within the panel joint leads to pillowing effect, wherein the joint surface are separated. A more recent corrosion-related incident, which happened almost 3 decades later, so 30 years more after the first example, occurred on Boeing 787 aircraft. In 2016, Japanese airline reported 2 cases in which their planes had to return to their departure airport due to engine-related irregularities. In 2019, a Norwegian plane suffered an engine failure, which forced the crew to shut down the engine and turn back to the airport. According to Rolls-Royce analysis, there were fatigue cracks in the engine's intermediate pressure turbine blade. These cracks are the result of sulfidation corrosion caused by chemical compound present in the atmosphere. And the propagation of these cracks is correlated with the number of flight cycles of an engine. So these two examples confirm the lingering problem of aircraft corrosion. So why does corrosion happen? It is a natural process. As we can see previously, the transformation of bauxite to aluminum alloy to aircraft structure injected a huge amount of energy to the metal. So the metal is in a metastable condition. To return to its natural stable condition, the metal must release the energy. And this is achieved through the process of corrosion. So in contact with water and oxygen in the air or in the water, there could be the formation of anode and cathode on the surface of aluminum. At the anode, an aluminum atom is oxidized, okay, like this, to aluminum ion and release 3 electrons. These 3 electrons are then consumed by the cathode, either here or here, by the reduction reaction of water. Corrosion of aluminum may take different forms depending on the specific condition. It may be an exfoliation corrosion of a cockpit kick plate angle due to water intrusion with the cockpit area, a microbiologically induced corrosion on fuel tank access door, and a galvanic corrosion under aluminum nickel bronze bushing. In particular, localized corrosion is of a high concern. A galvanic corrosion can occur when 2 dissimilar materials, such as carbon fiber composite and aluminum, are in electrical contact in the presence of water. Okay, to put this into perspective, by volume, 80% of Boeing 787 aircraft are composite. By weight, the material content is 50% composite, 2% aluminum, 15% titanium, 10% steel, and 5% other. Each aircraft contains about 32,000 kilograms of carbon fiber reinforced composite, made with 23 tons of carbon fiber. Composites are used in fuselage, wings, tail door, and interior. So galvanic corrosion becomes a very important issue as the use of composite increases, where the joint between the composite and the metal structure can be a source of this type of corrosion. 5 conditions allow galvanic corrosion to occur. First, active metal, aluminum, steel, stainless steel, titanium. Electrically conducting composite, usually carbon fiber composite. Electrical connection between metal and composite. Electrolyte, usually salt water, and oxygen. And also cracking due to hydrogen can also occur on the composite side due to the cathodic reaction of releasing hydrogen gas. There are 2 main groups of factors influencing corrosion. First, the design factor, including material selection, selection of surface protection system, drainage, use of sealing to eliminate crevices, use of corrosion inhibitor compounds, and access for maintenance. Second, the operating factors, including internal environment, condensation on internal surfaces, spillage of liquid in the cargo compartment, leaks in the toilet or kitchen, clothes or humid insulator in contact with metal surfaces, rainwater that going into the cabin, external environment like geographical zone near the coast or industrial environment, flight routes, volcanic ash, aircraft use, salting of runway, seaplane runway, also maintenance practice like using organic coating, like the organic coating deterioration. I think the example of external environment are very concerning for Indonesia, as we are surrounded by water. We are also surrounded by volcanoes. So corrosion might directly influence airworthiness. We may define airworthiness as the capacity of the aircraft to withstand all design loads according to the fail-safe concept during its service life without serious damage. The previous two examples of corrosion-related incident taught us that an uncontrolled corrosion can synergize with mechanical fatigue, resulting in unpredictable crack initiation and propagation. There is a need for corrosion prevention and control during service, the Corrosion Prevention and Control Program, CPCP, and this can be realized through a maintenance program that define the corrosion grade. 3 grades of corrosion exist. First, grade 1, corrosion is encountered in the successive inspection interval within permissible limits. Grade 2, corrosion is encountered in successive inspection intervals exceeding the permissible limit. And grade 3, corrosion is encountered in the first or subsequent inspection and is considered as urgent airworthiness problem. Corrosion is a natural process. We cannot completely stop it, but we can control it. We can reduce the risk of aircraft corrosion for example, by a proper selection of materials, a better drainage and strategically placed, using the last primer coatings and enamels, use of sealants to eliminate the entry of moisture into structural joints, and electrical insulation for composite aluminum joints to avoid galvanic corrosion. Boeing applies a corrosion risk evaluation to their 777 aircraft, which consider parameters such as, we take an example of Boeing practice. They consider different parameters, such as environmental severity, that is determined by the aircraft assembly location. As we know, Boeing has 3 production facilities, 2 in Washington, northern United States, and 1 in North Carolina, southern US. And also they have 1 delivery and livery facilities in China. They also consider electrical insulation scheme at the connection between composite and metal, as this example. They put a sealing, carbon glass fiber sealing seal between the carbon fiber composite and the metals to avoid electrical contact and thus avoid galvanic corrosion. They also consider vulnerability of the protection system against damage. So I think we can adopt their strategy, especially for environmental security in Indonesia, which is very severe in terms of corrosion to the airplane. So that's all I can share with you for this afternoon. Rampung dawuh tuntas panandika. Thank you very much for your attention. I return back the time to Mr. Ahmad Bahrawi. Thank you very much for your attention.
Thank thank you, Dr. Hendra, for the presentations about the materials. So, do you have time for Q&A? Sort, maybe for 3 minutes or maybe for one question.
We can also discuss in Bahasa if you like, but maybe I will use more English, especially for term that I don't know the.
That's no problem for us. Ya, silakan mungkin ada satu pertanyaan untuk Prof. Hendra. Tadi sudah menyampaikan tentang material selection dan juga about the corrosion faced by the structure of the aircraft. Ada? Tidak? Oh, sepertinya sudah jelas Prof. Hendra dari teman-teman di sini. You have So, Dr. Hendra already explained about the composition of the Airbus 380, the biggest aircraft in the world for now. So it's a compromise of aluminum 61% and then composites 22% and titanium 5% and steel 5%. Why do aluminum be the first choice? Because of the strength and then the lightweight and also the corrosion resistance. So the corrosion is something need to give more attention for, because it will affect the other structures of the corrosion. So there are some factors influencing the corrosion, and also from the identification then we can do the corrosion control. So thank you very much, Prof. Hendra, for your time.
You're welcome.
Thank you, and also have a safe flight back to Canada.
Yeah,
And I hope you success on your business in Australia. Thank you, Prof. Hendra.
Thank you.
See you again. Okay, we give applause to Prof. Hendra. Okay, then our third speaker will be Professor Josephat Tetuko Sri Sumantio. Selamat pagi, Prof.
Selamat pagi, Pak Ahmad, ya, dan terima kasih juga atas undangannya, dan selamat pagi juga untuk para hadirin sekalian. Ya.
Siap. Apa kabar Jepang, Prof? Dingin?
Baik-baik, ya, mulai dingin aja.
Siap, Prof.
Terima kasih.
Okay. So, Professor Josephat Tetuko Sri Sumantio is our next speaker. He is an expert in the field of remote sensing and has made significant contribution to the development of radar technology for disaster management and environmental monitoring. So, ladies and gentlemen, please welcome Professor Josephat Tetuko Sri Sumantio. The time is yours, Prof.
Okay, yeah, thank you very much. Yes, I think as you already could see my slide.
Not yet.
Oh, not yet? I'm already shared.
Okay, we can see your CV. Is that?
Oh, okay, yeah, yes.
Okay.
This is my slide. Yeah.
Okay.
Okay, first is thank you very much to moderator Bapak Ahmad Barawi, and then also to Bapak Dr. Wisnu Handoko, the head of the Human Resources Development of the Transportation Agency of Indonesia, and also the Captain Daniel Dewantoro Rumani, the director of the Indonesia Civil Pilot Banyuwangi, and also the keynote speaker, yes, Dr. Aisyah Indah Palupi, Dr. Hendra Hermawan, and also Professor Yainal Arifin, and also Professor Said Ahmed. Yeah, and thank you very much for the invitation today. Yes, I want to share about what we already developed in my laboratory. My name is Josephat Tetuko Sri Sumantio from Chiba University. I'm as the head division of the disaster data analysis at the Faculty of Medicine of Chiba University, and also the right now is also to be the professor in health and disease omics center of the Chiba University. And my permanent position is at the Center for Environmental Remote Sensing at Chiba University, and also at the Department of Teknik Elektro Universitas 11 Maret. Okay, from the expertise of my research is especially the synthetic aperture radar and also some of the platform for the aircraft, unmanned aerial vehicle, and also the micro satellite. For the detail is you can also find my what is live in the Kick Andy at you can find in the YouTube, and then just put the Kick Andy and Anak Kolong, because I'm one of the children of the my father is the Kopaskat, Komando Pasukan Gerak Cepat TNI AU. Okay, this is my brief introduction, and today I want to show to you about the development of innovative microwave remote sensor for the transportation infrastructure monitoring. Okay, this is some of my result in my research is I developed the little bit large scale of the unmanned aerial vehicle. We call it the GX1, GX2. GX is means Josaphat Laboratory Experimental Unmanned Aerial Vehicle. Yes, that we developed this one is to on board of our sensor that called the synthetic aperture radar. And also I already developed some of the radar from the CN235 aircraft, and also from the Boeing 737, and also the micro satellite. From the aircraft and the airborne on board, yes, the circularly polarized synthetic aperture radar, you can find my new book that published last April. Yes, this is the detail of how to develop and the hardware, and also how to implement of the application of the circularly polarized synthetic aperture radar. Okay, this is the content of my talk. Okay, I will skip because just 25 minutes. And it is some of the radar that I'm already developed. And thank you very much for the Indonesian Air Force that already installed for the experiment for my radar from the Boeing 737 and CN235 of the Squadron 5 at Makassar, and also from the Cessna at Academy of the Air Force at Lanut Adi Sucipto. And this is my drone itself, and also microsatellite. The concept of the circularly polarized synthetic aperture radar on the CPSAR, this is my patent at Japan. My radar is we can transmit left-handed circular polarization. It is the wave that we rotate to the left side, and also the right-handed circular polarization. Yeah, and after that is scattered by the object on the ground. Yes, today I want to talk about the how to observe the infrastructure, especially for the for the air transportation, and then we will get the scattering wave, and then we process, and you can get the image like this one. This is one of example of from my radar. My radar is use the microwave, so it means the wavelength is larger than compared to the water drop of the cloud. So it means we can penetrate the cloud, and then you can get the ground scattering is very clear, and you can also operate in the nighttime because the optic sensor like the camera is you cannot use in the nighttime, but my sensor you can use in the nighttime too. It means 24 hours you can use my radar. And it is in the roadmap of my laboratory. My laboratory is Josaphat Microwave Remote Sensing Laboratory, or Josaphat Laboratory, that we develop many radar, and also the some on the platform, and then we can also it is in the micro satellite, and now we also develop the HAPS high altitude platform that it is in the wingspan is 28 meter. Actually, before the COVID, I plan to fly this our drone at the Lanut Bia, yes, at Papua, but unfortunately, okay. Later is now we still arrange again, and we want to fly at Lanut Bia, and also Lanut Morotai. And okay, this is from the ground and flight test is already finished, and then now we plan to launch our 5 microsatellite, and I hope we can cover our planet. And we also develop from the moon observation and also the Mars observation. It is the roadmap of the development of our system and also radar system, and also for the platform system. And right now we already finished here, and then now we develop the GX2D. D is for the dropping, because we want to drop the medicine and some of the food and some of the for the emergency goods or stuff, yeah, to help some people in the disaster area. And also it is in the S is sensor. Now we develop from the sensor on board the unmanned aerial vehicle. It is in the GX1 and GX2, yeah, and it is our microsatellite. And okay, this is before the COVID is we already finished some of the and also prove some of our radar, imaging radar, and now we develop some of the drone that when the flight endurance is more than 2 hours. And okay, and it is the radar itself, and with the platform we already proven for the UAV and also from the aircraft, and now we're developing from the microsatellite. From the detail about our research, as you can read from the airborne SAR is like this one in this book, and next is from the microsatellite SAR in this book, yeah, and then from the unmanned aerial vehicle, yes, on the drone based on the synthetic aperture radar, you can read in this book, yeah. Okay, one of the example of our images. The image of the synthetic aperture, you can get the information of the intensity, phase, and also the polarization. I want to show you about the application of this image later. Yeah, it is our hubs. Yeah, when the wingspan is 28 meter, that we can fly. One flight is more than 6 months. Yeah, and it is using the solar panel, and then this part is GMRS, in the radar that developed in my laboratory. And then I hope we can fly soon, and then we still arrange with the Indonesian authority to fly at eastern of the Indonesia. And from the drone itself, GX2S, S in the sensor. Sensor is it is in the sensor. For example, it is our sensor that installed in this GX1 before. It is from the L-band synthetic aperture radar. And this radar itself already contributed from the Malaysian government from the in the SATREP program. It is in the under the JST and JICA program of the Japanese government to transfer the technology from the Malaysian government. And now I enlarge this function of my drone when the wingspan is 6.6 meter, and when the payload is about 25 kilogram with the some of the sensor here. Especially the synthetic aperture radar. And for the dropping, and we put some of the container here with the payload 25 to 30 kilogram, and then we can drop to the disaster area. From the mission, yes, this is our program from the platform and also the synthetic aperture radar. We develop especially from the disaster monitoring and natural resources observation. We have the collaboration with Pertamina in Indonesia, and also the search and rescue. Yes, it is with the Basarnas, and home security and anti-terrorism. We arrange with some of the institutions in Indonesia right now. And also the infrastructure, I think we have already some of the collaboration with Indonesia and another government in the world, yes, especially from the Malaysian government and Taiwanese aerospace agency and Korean aerospace agency, yeah, from the infrastructure monitoring. It is one example that we implemented to image processing to detect and predict about the land deformation at the east-west highway. Yes, I think highway is depend on the soil type. It is sometimes it's very fragile, and then it's very easy to move, and then landslide is happened, like at this part at the Cameroon highland at Malay Peninsula. For the detail of some of the examples, you can read my paper in IEEE DGRS. And for the airborne SAR is some of the aerospace agency like JAXA of Japan, and then the DLR of the Germany and United States of the NASA. It is all is the linear polarization. It is just work in horizontal and vertical polarization. But my radar is working in circular polarization. You can get any information with any angle. Yes, it is more precise compared to the conventional one. And some of the agency already approved my invention, the circular polarization synthetic aperture radar. Some years ago, is the Chinese science agency of the science. Yes, CAS is already proved that my radar is I think in the best one in the world right now. Yeah. Okay, it is some of the picture that we did some of experiment with my student is from come from many countries, from Malaysia, Germany, and also from Japan and some other country, also the Pakistan and so on. It is we work together and to realize our radar, and then we did some flight tests in Indonesia. It is at Lanut Adi Sucipto. And with thank you very much from the Akademi Angkatan Udara that install our radar in this Cessna 172. Yes, and also we developed some material we call it the poly material. It's very strong, and now this material also used by the big company in Japan called in the SoftBank. Okay, this is from the CN235 that we also developed the antenna by ourselves, and we put in this inside this radome, and this is our radar system that installed in the Cessna, the CN235 aircraft for the transmitter, receiver, and also some of the controller. Yeah, and we developed all is by handmade by our laboratory in Josaphat laboratory. It is one situation that we did some of experiment with which and we touched the radome. Yes, and we got a very nice result. And it is the first image of the circular polarized synthetic aperture radar of the Lanut Sultan Hasanuddin. Yeah, it is very clear with the detail as 37.5 centimeter of the resolution. And compared to the optical camera, yes, this is covered by the cloud, but our image is very clear. And now we plan to bidding for the BIG, yeah, Badan Informasi Geospatial, that plan to make the mapping of Indonesia. I hope now we want to bidding, and I hope we can use our radar to help Indonesian government to mapping the first in the Celebes island. And it is one of the another example of our image. Yes, it is in the real image, and then we just cropping and compare with the optical image from the Google. It is in the complex of Pangkosek, yes, at the Makassar, and it's very clear. And then you can also get some information of the pillar, because our radar can penetrate inside the housing on the building. Yeah, this is, I think, it's very clear. And if you zoom up, you can get some of the situation inside the building itself. This is the full polarimetric of our CPSAR, yeah, with the left-handed and right-handed. It is in the composition, it's like this one. And the characteristic of the circular polarization in the cross polarization is stronger compared to the co-polarization. It is opposite with the linear polarization, and it's very clear and with the high resolution. Okay, this is one example and very clear, and you can get also the structure of the tree, yes, by using this radar images. Yeah, from the illegal fishing and also the ship, sometimes it's the AIS is turn off, even turn off, and we can get the information about the ship, yes, even in the night time. Okay, there's some of the example at Pangkajene, and now we will want to have the BPN. Yes, BPN. We want to plan. We already developed some of the application that we can mapping automatically, and we can deliver the peta bidang. Yes, we call it the peta bidang because we have the problem that about 34 million of the bidang peta tanah of bidang is not yet certified by the Indonesian government. So I hope we can help the Indonesian government and we can get the more income from the certificate of the land. Yes, this is the microsatellite developed in my laboratory with my student from Pakistan, Indonesia. Now is to be Brin before in the Lapan, and Katia is from Brazil that now work in the European Space Agency, and Chua is now working at the Xiamen University of the Malaysia. Yes, if some of you want to enroll to my laboratory, we are very welcome in to accept you in Josaphat Laboratory, because I created many programs, including the double degree program for with the Indonesian academic institution. Yeah, I hope some of you also can enroll to my laboratory. Okay, this is the CPSAR onboard microsatellite. We have many company in Japan, Korea, Taiwan, and Europe. Yeah, to develop the microsatellite. This is microsatellite SAR. Yeah, this idea is, I think, is in the first in the world is by myself in 2002. Yeah, and now many company is already developed and also launched this microsatellite SAR. Okay, finally, I want to show you some of the application of the image of the synthetic aperture radar using because from the image you can get the intensity, phase, and the polarization. First is the intensity, and you can derive the backscattering coefficient, and you can implement to estimate the thickness of, for example, it is the core, we call it the batu bara in Indonesia, and how to estimate is you can read my paper in detail in International Journal of Remote Sensing and some of the IEEE about the technique how to detect of the core, the thickness. Yes, even the coal is not some institution or country don't want to use the coal, but I hope in the future we can develop some of the technique that we can use the coal more efficient and eco. Yeah. Okay, and the phase. Yeah. It in the application for the coherency to detect upon the disaster area which houses is cracked and also some of tunggu bentar ya. Okay, this is one of the example that I observed the disaster at the Central Java earthquake. Yeah, here is the Lanut Adi Sucipto, and you can find it is the some of the houses that's destroyed by the earthquake by using this. It's very simple equation, just coherency analysis, and it's very clear. And then you can help them how to find the destroyed area. Okay, and next about the interferometry. Yeah, for the interferometry is use the two images of the synthetic aperture radar, and you can get the information of the land deformation horizontally, dx, and also the vertically, or the dz. Okay, and you can derive the phase here, and then you can get the information about how many centimeter or millimeter change. Yeah, for the detail is you can read in my paper here. Yes, at the IEEE TG RS. Yeah. Okay, and then okay, for the detail is like this one. And for example, it is when I observe land deformation at the Sidoarjo and close to the Lanut Juanda here. Yeah, and using the just two image to know about the how many centimeter or millimeter in 1 year. Yes, that land subsidence or land land deformation. Yeah. For the detail is using, for example, it is using the X band. It is Terasar X. Yeah. One of the change, yeah, from the red to the red is about 12 centimeter, change, yeah, in 1 year, yeah. And for example, this area is the Cengkareng, and here is Lanut Halim. Why Lanut Halim is, before is almost every year is flood, yes, because in this area also some of the subsidence. And for the transportation, the road, yes, for example, this area is every year is 6 centimeters subside. So why the road is, some bridge is failed, yeah, and okay, and also some area also flood is happen because land subsidence, and you can use the technique of the interferometric to know about the land deformation. I think very easy, and if you want to learn about this one, you can come to Josaphat Laboratory, and you can learn about how to apply this synthetic aperture radar. And we can also detect the thickness of the volcanic ash. I think when the Semeru eruption. Yeah. Okay. And next, it is land subsidence of the Lapindo. And next, it is in the Mount Merapi explosion because it is close to the Lanut Adu Sucipto, and it's very dangerous that affect to the aviation field. Yeah. And you can estimate about the thickness of the volcanic ash, and based on this one is you will know about why Mbah Marijan is die. Yeah, it is because this impact. Yes, fortunately, the standing I got some of the award. Yes, best paper award about how to derive this volcanic ash thickness. Yeah. And next is the permanent, interferometric. It is to know about the speed of the land deformation. Yeah, and you can find this area in the Lanut Lanut Bandung. Yes, and here is the Lanut Sulaiman, because I born at Lanut Sulaiman at the Kopasgat here. Yeah, and you can find close here in the Dayakolot. Dayakolot every year is 15 centimeter, subside. Yeah, and this part in the Cimahi, this Cimahi area is also subside when the speed is 15 centimeter every year. Yeah, it is. I think it's very dangerous, and you can find at the at the edge of the Hussein. Yeah, Lanut Hussein is a little bit subside. Yeah, it is. I think is in the future is very dangerous. So we need to check about the flatness of the runway. Okay, next is about the sedimentation. It is not so relation to the. Okay, here is the seaport. Yes, seaport is the speed of the sedimentation here at the eastern part of the Jakarta Strait. Yeah, here is every year 35 meter, sedimented, and I think in the future will give the impact to the deep seaport plan in this area. Yeah, I think here is the head of the Tanjung Priok, authority, and we must check, yes, and observe the sedimentation at the northern part of the Jakarta. For the detail about the technique, as you can read my paper at the IEEE JRSL. And the detail is okay, you can read in this paper. And finally, about the polarimetric. Polarimetric is to know about the volumetric scattering. It is from the forest, and the surface scattering, the blue is from the flat area. For example, here the Lanut Juanda, and also the double bonds. It is from the man-made area, including the bridge, a shape, and also the building. Yeah. Okay, next is Jakarta. Yes, you can also observe using the polarimetric SAR to know it is in the Cengkareng and here in the Lanut Budiarto. Yes, Curug. Yes, and here in the Pondok Cabe. Yes, and you can implement this synthetic aperture radar to know about the condition of the infrastructure our transportation, including the highway and also the railway. Yes, you can detect every year how many centimeter or how many millimeter move. Yes, it is. I think it's very accurate and very detailed. Yeah. Okay. Because I have some of the work in Toba area. It is close to the Bandara Silangit, the new area here. Yes, how to develop the Toba area. Yes, I hope we can establish more big project in Toba area. Okay, it is the final one. We have the work, yes, using the Himawari H to detect and predict the turbulence. Yes, air turbulence using the satellite images. One of my student, it is work of my student PhD, double degree program with the Universitas Gajah Mada. Yes, to know about the which area the turbulence will happen. Yeah, it is a very important technique, and it is our technique we call in the spatial temperature difference to know about the turbulent area will happen in this which area. Yeah, and also using the cloud true color and also the land wave. It is all is derived by using the Himawari 8 and Himawari 9 of the meteorological satellite. Yeah. Okay, thank you very much for the invitation, and I hope some of you can learn about what we already developed. It's not just the hardware, we also develop the platform and also some of the application. Yes, if you want to know more about what we are doing in Yosafat Laboratory, my laboratory, you can call me, you can see or just searching Yosafat Laboratory or JMRSL. Yes, I think you can get more detailed information about our activity. Thank you very much. And the time I give back to Pak Ahmad Barawi. Yeah, thank you.
Thank you very much, Prof, for the presentation about microwave remote sensing for transportation infrastructure monitoring. From your presentation, we know that how beneficial your radar, not only for monitoring the infrastructures, but also to predict about what will happen about our infrastructure in the future. So thank you very much once again, Prof. I hope you have a wonderful day for today, and also we hope that one of our students will be able to join your laboratory at the Josafat Laboratory. Once again, thank you very much. Terima kasih banyak, Bapak.
Yeah, you're welcome. Thank you very much. Yeah, and keep healthy. Yeah.
Siap. Terima kasih, Bapak. Baik, kita beri tepuk tangan untuk Bapak Profesor Josafat untuk paparan luar biasa. Oke, baik teman-teman semua, Bapak Ibu, ladies and gentlemen, our next presenter will be Professor Insinyur Zainal Arifin Hasibuan from Universitas Dian Nuswantoro, and also from the University of Indonesia atau Universitas Indonesia. Namun saya mendapat kabar bahwa beliau sedang dalam perjalanan sehingga tidak bisa menyampaikan in person, tidak bisa menyampaikan secara langsung, dan diinformasikan oleh panitia bahwa sudah disiapkan video pemaparan oleh beliau. Jadi sebelum istirahat kita saksikan pemaparan oleh Profesor Insinyur Zainal Arifin Hasibuan. Kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. A very good morning to everybody who participate in this international conference. Forgive me for not present in front of all the participants due to the works that I face right now. So the presentation that I would like to deliver this morning, the title is Making Artificial Intelligence at Work, the way forward to accelerate digital transformations. So the idea behind this presentation is how we utilize how we use this artificial intelligence in our daily life, so that we can feel the benefit, not just the theory or not just the presentation in the conference like this. So that's the idea behind it. So let's begin with the definition of artificial intelligence. As we can see here, the artificial intelligence means that how the computer try to mimic the way human being thinking. So artificial intelligence is the theory and development of computer system able to perform tasks that normally require human intelligence. So it is mimicking the way how humans think. So again, underline the mimicking. Mimicking means memiripkan ya, seperti bagaimana manusia berpikir. So actually, what artificial intelligence is doing, more or less, is how to decompose the problems or the issues, how making the abstractions, how to recognize the patterns, and how to work algorithmically, so systematically, something like that. So these four main things that artificial can do best as the queen of science. I make it up that I said the artificial intelligence as the queen of science. More details, artificial intelligence as the queen of science, actually they are doing normal things, but we need that normal things in our daily life. For example, how to identify objects, how to diagnose patterns or what you call it, symptoms. Yeah, how to diagnose symptoms, how to recognize patterns, how to clusterize or clusterizations, a group of object or several things, and also at the same token, how to classify the things, the object, whatever we have in the in this world, yeah, in the our daily activities of our work, and also how to make prescriptions. So those are the more interpretations on what the artificial intelligence can do. So once we recognize the role of this artificial intelligence, hopefully we can have more understandings, the limitations, and also the power of artificial intelligence. It doesn't mean that artificial intelligence can do everything. When it structures the issue, more or less artificial intelligence can do like I just mentioned. And furthermore, artificial intelligence, this is the difference when we first learned artificial intelligence in the early 1980s. Most of them is just theory, using small sample of data. Now, artificial intelligence with the availability and the visibility of big data, the needs and the use and the benefit of artificial intelligence more clearer, more real. So again, I can say here that artificial intelligence needs big data, and that big data not only structures data, it can be included semi-structured data as well as unstructured data. I call it everything is data, nothing being waste. Whatever we do, whatever we go, wherever we go, wherever we talk, whatever, everything, multiple sources of data, we call it big data, and everything can be a data. So furthermore, as we can see in these pictures, artificial intelligence here needs big data. Big data, furthermore, need to be compute, not ready just that, yeah, to use in the artificial intelligence, but it is has to compute. The computation of big data, we call it data science. Actually, data science is the advanced or the more developments of statistics that we have learned before. So as we can see here, big data can be image, text, video, number, audio, etc. And data science is more or less the models and data analytic, data interpretations, and also data attributes. Those are the input to the artificial intelligence. The artificial intelligence, furthermore, also can be divided more detailed into machine learning, and the subset of the machine learning, we call it deep learning. All together, we call it artificial intelligence. So the result of this artificial intelligence computations, we can divide it into two things. One, what we call artificial intelligence humanoid robot, like how the robot work, move, talk, etc. And the second thing is artificial intelligence smart automation systems. And I focus more on the second one, which is artificial intelligence automation systems. As we can see here further, artificial intelligence actually the mathematical computation, statistical computation that we learned before, but with the big data, the use of it is more feasible, it's more real, it's more implementable. As we can see here, all the diagram here shows that how the artificial intelligence be related to something that we have learned before. So it's no this to do identification, classification, clusterization, prediction, etc. More or less we use all these methods. Unless we are really good in the theoretical or basic research, we can try to play around with this theory. But mostly right now, the artificial intelligence just use the existing algorithm that we can see here, the further algorithm that mostly used, as you can see here, logistic regression, linear discrimination, classification and regression trees, and naive bias, k-nearest neighbors, so nothing very rare or very what you call that asing, yeah. All this algorithm, we more or less recognize this algorithm. But again, what we are lacking so far, we are using this model or algorithms with a small samples of data. So that's why we cannot get the full benefit of artificial intelligence. And let's see the case study that we have done so far. Yeah, my research. First, what we call detecting level of susceptibility to tuberculosis distribution in Semarang City. Jadi ini menangkap penyebaran tingkat kerentanan tuberculosis. Ya, gunanya it used for the program identification, personalization, etc. As we can see here, it's involved a lot of source of data. Sistem informasi tuberculosis, smart betul sistem informasi, survey, observation, BPS. So this is the most challenge in the process of using artificial intelligence. How to set up the big data and make this big data into a working data set, a lot of pre-processing. So I would like to stress here, a lot of pre-processing in that data set development due to different measurement, different types of data. As I mentioned before, some of data are very well structured, some of the data are semi-structured, and some of data unstructured at all. But we combine all together. We do a lot of pre-processing, normalizing, missing value, interpolation, etc., etc. So once we have this data set, it's ready to compute. Yeah, as we can see here, the computation is really, as you can see, the computer compute just number. So if we have qualitative data, we have to categorize it. So we have to learn data category like nominal, ordinal, etc. And the nature of that category we have recognized. Now the power of computation, all this nominal data and ordinal data also can combine with the numerical data to compute something. As we can see here, the computation, I just give one example we use to reduce the big size of data sets to reduce it using principal component analysis. As you can see here, we have very large millions of data and also hundreds of attributes, and then we reduce it using principal component analysis. I'm not gonna tell more about the detail of principal component analysis, but I'm just gonna say with the principal component analysis we can reduce dimension, so without losing information. And from there, I think I would like to stress this is the underlining when we learn linear algebra and also matrix. There is an eigenvalue, etc. So from this principal component analysis, we're ready to compute. As you can see here, the big data set, when once we computed, first we would like the scatter plot. We would like to see the distribution of that data into multi-dimension. There are many dimensions, but in the scatter plot, we just show it 3-dimension. And then from this 3-dimension, it show what we call hidden structures. Structure yang tersembunyi. As you can see here, the dot represent the object with a different color. So it means it is true that in that big data set, once we reduce the dimension, the structures can be revealed with the computation. The scatter plot, now we are using just regular tools. It's very powerful. Once we saw this hidden structure, which is cluster, for example, we apply the cluster analysis. We just use simply k-means. And as we can see here, we see the structures, we see the substructures, we see the sub-substructure, etc. So we just can simply cut the threshold. For example, once I cut the threshold right here, hopefully you can see my draw here. See, once I cut here, we just can simply get cluster 1, cluster 2, cluster 3, cluster 4. When we cut lower than that, we get more cluster. So again, once we get that cluster, we interpret that clusters, what it means, because we can go back again to the variable, to the attribute that constitute the clusters, and we name it. We name it, or regularly we call it, we label it. The label used to, the label used to classification. Once we have the classification, we just simply implement it to the spatial space. As you can see here, this is the Semarang city, our project called Semarang Towards Zero Tuberculosis. As you can see here, the color of the spatial city of Semarang is different. We can see that more red, it is more explore to the tuberculosis. Less than red, it's a middle threat, and also the less red or orange or whatever the color we put it, it is not really fully threat by tuberculosis distribution. So from this spatial space, tingkat kelurahan, kecamatan, kota, even national, we can formulate their program that suitable to each kind of degree of susceptibility. Jadi programnya itu tidak satu untuk semua, tapi sesuai dengan tingkat kerentanan tuberculosis. So this is the power of artificial intelligence that you can see, from the computation into a simple data presentation. This is what we call a dashboard. Okay, secondly, the project that we have also smart waste management system using the smart result for small medium enterprise. This is very straightforward. We apply IoT to capture amounts or volumes of waste, sampah, and then we differentiate kinds of waste like organic, unorganic. Unorganic, we divide it into several things, also plastic, irons, besi, kayu, etc. We use all the artificial intelligence to capture the data using IoT, and then also combine all the data from several sites with a blockchain, and then at the end we have this big volume of data. We classify it, and then we use it. This is the very interesting thing. We use it, the result, to develop small medium enterprise, whether it is recycle the plastic, recycle the paper, recycle the rubber, yeah, repair the computers, repair the auto part. It is what we call recycle, repair or refabrications, remanufacturing, reuse and reduce, etc. So also this the power of artificial intelligence from capturing the waste and then turning into economic activities for small medium enterprise. Okay, another project that we have here, that's small medium enterprise that we have 67% our GDP contribute to the small medium enterprise. 97% of our labor force, yeah, adopt or absorbed by small medium enterprise. So we would like to classify what kinds of small medium enterprise that we have. The purpose of this classification, so we know what kind of applications that's suitable to each classification. So again, we use this simple clustering, of course, capturing the data from social media, from website, from interview, from secondary data from Ministry of Small Medium Enterprise and Corporation, etc., etc. So again, this is also very powerful. As we can see here, the result, we know that application 1 is suitable to once the small medium need operation, managerial, strategical. And by having so, we can help the small medium enterprise to provide application they need. Okay, there's our third project that going on. And the fourth project we have is AI-based coral reef conservation. As we can see, the coral, it is growth, but due to the pollution, etc., a lot of disturbance, gangguan to the growth of this coral. The consequences is the coral will die. Also, the habitats around the coral also not healthy, etc. So we would like to capture the degree of damage of coral reef. And by having the data, by having the result, as you can see here, the graphic give a different color. It shows that need a different treatment. So again, by having artificial intelligence to compute this big data from coral reef, we can formulate intervention program to secure our coral. This is a very wealth the very what we call it kekayaan alam kita yang luar biasa. Okay, and last things project that we have is how to conserve our cultural heritage and natural history. Yeah, as we can see here, the data we just extracted from Google, and then we have all kinds of like a traditional house, traditional language, ethnic language, etc. We combine all together, and then we try to provide interface that how to classify, to identify, and also to conserve, to preserve our cultural heritage. And last things, okay, this the wise word that I got from Chinese. I think we all know. We heard and I forgot. So just like this presentation, all the participants will hear. Once the presentation or the conference over, I'm sure that everyone will forget what I present. Okay, but I already present also the examples. Hopefully, by the examples, we can remember. So I see and I remember. I give a lot of examples, and hopefully, all the participants at least remember what the powers of artificial intelligence can do. And last things, I do and understand. So I hope all the participants, including the lecturers, the researchers, practice it, do it, not just listening it, not just remembering, do it. And once we do it, we understand. And it's not as simple as I present. As I mentioned before, collecting data, there's a big challenge because we have every data except that we want to collect. Jadi kita punya semua data kecuali yang kita perlukan mau kita kumpulkan. So I think that's all my presentation. Hopefully benefit to all. Ya, lebih kurang mohon maaf. Saya sudahi. Wassalamualaikum warahmatullahi wabarakatuh.
Baik Bapak dan Ibu semua, kita beri tepuk tangan untuk para presenter kita. We give applause to all our speakers. So we have heard four speakers present the material. First one was Professor Dr. Insinyur Aisyah Endah Palupi, MPD. She explained about the TVET, Training Vocational and Education in Philippines, and the second one was Prof. Hendra explained to us about the material, and the third one was Professor Josaphat about remote sensing, what is used in our daily life, and also what is benefits for us in aviation and also in other sector of our lives. And the last one was Prof. Zainal presenting about the artificial intelligence. So big data plus data science will be the artificial intelligence. And artificial intelligence, the use of artificial intelligence is the automation system or humanoid robot. And the last presentation was quote from professor that we do not only hear the information, but also we need to do something in order that we can practicing what we have learned and will implement in our daily life. That's all for our from our four speakers, and our last speakers, the fifth speaker will be present after lunch break. And we give applause to all of us. Tepuk tangan untuk kita semua. Dan untuk paparan yang kelima nanti akan disampaikan setelah break makan siang. Dan untuk selanjutnya acara kami kembalikan ke pembawa acara. Kami persilakan. Terima kasih.
Terima kasih kepada Pak Barawi. Well, thank you for all of the honorable speakers for the amazing session. And we would like to invite all of the speakers to the IT team. Can you pin all of the speakers into the screen? And for our next session will be there's e-certificate handover to all of our honorable speakers. To the IT team, can you pin and show all of our five speakers? Okay, for a while, the next session will be certificate handover to our three amazing co-hosts. I would like to invite Captain Daniel Dewantoro Romani for presenting the certificate. The representative from PPI Curug will be Mr. Imam Sonhaji, SSIT MM, as the head of the Air Traffic Control Training Division from PPI Curug. And from the Institut Teknologi 10 November will be Mrs. Insinyur Ervina, ME PhD, as the Air Transportation Researcher. And the co-host from Universitas Pembangunan Pancabudi Medan will be joined via Zoom, represented by Bapak Hamdani STMT as the Dean of Faculty of Science and Technology, University of Pembangunan Pancabudi Medan. Thank you. First from Captain Daniel to Politeknik Penerbangan Indonesia Curug for the certificate of appreciation as the co-host for today's conference. IT team, can you show the other co-host that is joined via Zoom? Mr. Hamdani. Hamdani STMT. Okay, to all of the co-hosts who join us offline, you can continue to your seat. Thank you. Okay.
Ladies and gentlemen, let us now take an afternoon break from today's session. We will continue our session on 1 p.m. To our Zoom attendees, please remain on the Zoom meeting during this afternoon break. Thank you.
Baik, kepada seluruh Bapak Ibu peserta, untuk acara hari ini kita break terlebih dahulu untuk break istirahat, sholat, dan makan siang. Dan acara akan kembali kita lanjutkan pada pukul 1 siang setelah makan siang. Terima kasih kepada seluruh peserta bisa menikmati makan siang yang telah disediakan oleh panitia. Terima kasih.
Baik, terima kasih. Selamat menikmati makan siangnya, Bapak Ibu sekalian.
Kalau mataku terpejam sunyinya malam, kalau hasratku membara hayal semakin tinggi, seribu asa hadir di sekelilingku, bangkitkan gairah hidup, sejuta harapan di dalam jiwaku, walau semua masih di dalam angan, jurang-jurang menghadangku, getarkan jiwa. Dekatnya kegelapan datang melanda, keraguan kini menjelma di dada, musnahkan segala asa, semua harapan yang dulu pernah ada tiada tersisa. Haruskah ku hidup dalam angan-angan, merengkuh ribuan impian? Haruskah ku lari dan terus berlari, mengejar bayang-bayang ilusi, bayang ilusi, fantasi, bayang ilusi. Haruskah ku hidup dalam angan-angan, merengkuh ribuan impian? Haruskah ku lari dan terus berlari, mengejar bayang-bayang ilusi? Merengkuh ribuan impian. Haruskah ku lari dan terus berlari, mengejar bayang-bayang ilusi, bayang ilusi, hanya fantasi, bayang ilusi, bayang ilusi.
take Tim Martin. I left my dawn on one side, and you can't hear it in my eyes when I tell I'm an Englishman in New York. See me walking down Fifth Avenue, walking camera at my side. I take it everywhere I walk. I'm an Englishman in New York. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. You better man as a someone say, Dan is a hero of the day. It takes a man to suffer, ignore and smile. Be yourself, no matter what I say. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. But I see property, can let you know the ready. You killing now, but I'm the only one. Jonathan is a birdie, I'm wearing this Jazzy. Night candles brighter than the sun. It takes more time, come back here to make you man. It takes more time, listen for a gun. You confront your enemies for the time you can earn. A gentleman will walk but never run. You better man as a someone say, then he's a hero of the day. It takes a man to suffer, ignore and smile. Be yourself, no matter what I say. Be yourself, no matter what I say. Oh, be yourself, no matter what I say. Be yourself, no matter what I say. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. Oh, I'm an alien. I'm a legal alien. I'm an Englishman in New York. Oh, ooh. I'm an Englishman in New York. I'm an Englishman in New York. Thank you. Englishman in New York. Oke, mungkin ada request lagu. Silakan Bapak Ibu. Mas Yasin mau request. Terima kasih loh tepuk tangannya, amazing sekali. Iya. Pak Yasin sama Fikri suruh nyanyi ya Pak Yasin. There was only you around me. We were young and wild and free. Though nothing can take you away from me. We've been told the world before, but that's all for now. You keep me coming back for more. And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And the love is all that I need, and the fun is there in your heart. There isn't too hard to see we're in heaven. Oh, on in your life you found someone who will turn your world around, bring you up when you're feeling down. Yeah, nothing can change what you mean to me. Oh, there's a lot that I could say, but just hold me now. 'Cause our love ain't like the way. And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And the love is all that I need, and the fun is there in your heart. Here isn't too hard to see we're in heaven. I've been waiting for so long for something to arrive, for love to come along. Now our dream are coming true. Took the good times and the bad. Yeah, I'll be standing there by you. Oh, oh, oh. Oh, oh, oh. And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And love is all that I need, and I found it there in your heart. Here isn't too hard to see we're in heaven, heaven. No. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And the love is all that I need, and our body is there in your heart. Here isn't too hard to see we're in heaven. Dari kejauhan tergambar cerita tentang kita, terpisah jarak dan waktu. ingin kuungkapkan rindu lewat kata indah. Tak cukup untuk dirimu, sebab kau terlalu indah. Dari sekedar kata, dunia berhenti sejenak menikmati indahmu. Dan apabila tak bersamamu, kupastikan ku jalani dunia tak seindah kemarin. Sederhana tertawamu sudah cukup lengkapi sempurnanya hidup bersamamu. Oh, 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 oh. Jika hariku lalui tanpa hawamu, percuma senyumku dengan dia. Dan apabila tak bersamamu, kupastikan ku jalani dunia tak seindah kemarin. Sederhana tertawamu sudah cukup lengkapi sempurnanya hidup bersamamu. Apabila tak bersamamu, kupastikan ku jalani dunia hidup bersamamu. Oh, 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 oh. Oh, 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 oh. Sebab kau terlalu indah. Dari sekadar kata, dunia berhenti sejenak menikmati indahmu. Thank you. Special song. Mau lidah nyanyi? Nyanyi lah. Lights to the night, the color paradise, healthy aims of your skin is a holy grail like God to find. Never knew that it could mean so much, so much. You the fear, I don't care, 'cause I've never been so hard. Follow me to the dark, let me take you past our satellites. You can see the words you brought to life, to life. So love me like you do, love, love, love me like you do. Love me like you do, love, love, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Every inch of your skin is a curl of paradise. Every inch of your skin is a holy grail I gotta find. And you can set my heart on fire, on fire. Yeah, I let you set the pace, 'cause I'm not thinking straight. And my hands spinning around, I can't see clear no more. What are you waiting for? Love me like you do, love, love, love me like you do. Love me like you do, love, love, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Love me like you do, love, love, love me like you do. Love me like you do, love, love, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Oh. Yeah, I let yourself to pace, 'cause I'm not thinking straight. My heart's beating around, I can't see clear no more. What are you waiting for? Love me like you do, love, love, love me like you do. Love me like you do, love, love, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Love me like you do, love, love, love me like you do. Love me like you do, love, love, love me like you do. Touch me like you do, touch me like you do. What are you waiting for? Oh. Terus melangkah melupakanmu, lelah hati perhatikan sikapmu. Jalan pikiranmu buatku ragu, tak mungkin ini tetap bertahan. Perlahan mimpi terasa mengganggu, ku coba untuk terus menjauh. Perlahan hatiku terbelenggu, ku coba untuk lanjutkan hidup. Engkau bukanlah segalaku, bukan tempat untuk hentikan langkahku. Usai sudah semua berlalu, biar hujan menghapus jejakmu. Terus melangkah melupakanmu, lelah hati perhatikan sikapmu. Jalan pikiranmu buatku ragu, tak mungkin ini tetap bertahan. Perlahan mimpi terasa mengganggu, ku coba untuk terus menjauh. Perlahan hatiku terbelenggu, ku coba untuk lanjutkan hidup. Engkau bukanlah segalaku, bukan tempat untuk hentikan langkahku. Usai sudah semua berlalu, biar hujan menghapus jejakmu. Lepaskan segalanya, lepaskan segalanya. Engkau bukanlah segalaku, bukan tempat untuk hentikan langkahku. Usai sudah semua berlalu, biar hujan menghapus jejakmu. Engkau bukanlah segalaku, bukan tempat untuk hentikan langkahku. Usai sudah semua berlalu, biar hujan menghapus jejakmu. Na 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 na. Baik, terima kasih. Baik, mungkin Bapak Ibu ada yang mau ikutan bernyanyi di sini, boleh sekali. Mungkin ada yang berkenan mau bernyanyi sama Mas Fikri. Yes. Hah? Oh, Pak Yasin. Suruh nyanyi loh Pak Yasin. Ku selalu mencoba untuk menguatkan hati dari kamu yang belum juga kembali. Ada satu keyakinan yang membuatku bertahan. Penantian ini kan terbayar pasti. Lihat aku sayang, yang sudah berjuang menunggumu datang menjemputmu pulang. Ingat selalu sayang, hatiku kau genggam. Aku takkan pergi, menunggu kamu di sini. jika bukan kepadamu, aku tidak tahu lagi pada siapa rindu ini kan ku beri. Pada siapa rindu ini kan ku beri. Silakan Pak, nyanyi bareng sini. Oh, lihat aku sayang yang sudah berjuang menunggumu datang menjemputmu pulang. Ingat selalu sayang, hatiku kau genggam. Aku takkan pergi menunggu kamu di sini. Di sini. Kasih Pak. Harusnya nyanyi bareng nih. Lihat aku sayang yang sudah berjuang menunggumu datang menjemputmu pulang. Ingat selalu sayang, hatiku kau genggam. Aku takkan pergi, aku takkan pergi menunggu kamu di sini. Wow, amazing. Terima kasih. Kau begitu sempurna, di mataku kau begitu indah. Kau membuat diriku akan selalu memujamu. Di setiap langkahku ku kan selalu memikirkan dirimu. Tak bisa ku bayangkan hidupku tanpa cintamu. Janganlah kau tinggalkan diriku, takkan mampu menghadapi semua. Hanya bersamamu ku akan bisa. Kau adalah darahku, kau adalah jantungku, kau adalah hidupku, lengkapi diriku. Oh sayangku, kau begitu Kau genggam tanganku saat diriku lemah dan terjatuh. Kau bisikan kata dan hapus semua sesalku. Janganlah kau tinggalkan diriku, takkan mampu menghadapi semua. Hanya bersamamu ku akan bisa. Engkau adalah darahku, engkau adalah jantungku, engkau adalah hidupku, lengkapi diriku. Oh sayangku, kau begitu sempurna, sempurna. Oh, janganlah kau tinggalkan diriku, takkan mampu menghadapi semua. Hanya bersamamu ku akan bisa. Engkau adalah darahku, engkau adalah jantungku, engkau adalah hidupku, lengkapi diriku. Oh sayangku, kau begitu adalah darahku, engkau adalah jantungku, engkau adalah hidupku, lengkapi diriku. Oh sayangku, kau begitu, sayangku, kau begitu sempurna, sempurna. Memang benar ku salah, tak menghargai perasaanmu dan menghancurkan rasa cintamu saat ku ingat dirimu. Harummu yang memeluk nafasku dan memberikan ku kehangatan. Terangnya 1000 bintang tak dapat menyamai cahaya keindahanmu dari wujudmu, dan aku tak mengizinkan cahayamu redup karenaku. Dan atas kesombonganku, andai ku tak membuang dirimu, menjadikan yang kedua atas cintaku. Janganlah keterpurukanku ini membuat kau membenciku selamanya dan membunuhku. Kita membuang dirimu, menjadikan yang kedua atas cintaku. Janganlah keterpurukanku ini membuat kau membenciku selamanya dan membunuhku. Andai ku tak membuang dirimu, menjadikan yang kedua atas cintaku. Janganlah keterpurukanku ini membuat engkau benci selamanya dan membunuhku. Hold my back prepared, I'm ready to go. I'm standing here outside your door. I have to wake you up to say goodbye, but the dawn is breaking, it's early morning. The taxi's waiting, he's blowing his horn. Already I'm so lonesome, I could die. So kiss me and smile for me. Tell me that you'll wait for me. Hold me like you'll never let me go. 'Cause I'm leaving on the jet plane. Don't know when I'll be back again. Oh babe, I had to go. There's so many times I let you down. So many times I blab around. I tell you no, they don't mean a thing. Every place I go, I think of you. Every song I sing for you. When I come back, I'll bring you wedding ring. So kiss me and smile for me. Tell me that you'll wait for me. Hold me like you'll never let me go. 'Cause I'm leaving on the jet plane. Don't know when I'll be back again. Oh babe, I had to go. Now the time has come to leave you. One more time, let me kiss you. And close your eyes and I'll be on my way. Dream about the days to come, when I won't have to live alone. About the times I won't have to say. So kiss me and smile for me. Tell me that you'll wait for me. Hold me like you'll never let me go. 'Cause I'm leaving on the jet plane. Don't know when I'll be back again. Oh babe, I had to go. So kiss me and smile for me. Tell me that you'll wait for me. Hold me like you'll never let me go. 'Cause I'm leaving on the jet plane. Don't know when I'll be back again. Oh babe, I had to go. Leaving on the jet plane. Leaving on the jet plane. Leaving on the jet plane. How Thank you. Terima kasih tepuk tangannya. Whenever I'm alone with you, you make me feel like I am home again. Whenever I'm alone with you, you make me feel like I am whole again. Whenever I'm alone with you, you make me feel like I am young again. Whenever I'm alone with you, you make me feel like I am fun again. However far away, and I will always love you. Whatever what I say, and I will always love you. Whatever what I say, and I will always love you. I will always love you. Whenever I'm alone with you, you make me feel like I am free again. Whenever I'm alone with you, you make me feel like I am clean again. Now never far away, and I will always love you. Whatever I say, and I will always love you. Whatever word I say, and I will always love you, and I will always love you. Love you. Love you. Fly me to the moon, let me place among the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. Oh, in other words, baby, kiss me. Fill my heart heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In all the world, please be true. Oh, in all the world, I love you. Oh, fly me to the moon, let me place among the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. In other words, baby, kiss me. Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. Oh, in other words, I love you. In other words, I love you. Oh, in other words, I love you. Thank you. Fly me to the moon. How well is for the way you look at me. How is for the only one I see. He is very, very extraordinary. He's even more than anyone that you adore can love. He's all that I can give to you. Love is more than just a game for two. Two in love can make. Take my heart and please don't break it. Love was made for me and you. Oh, Al, is for the way you look at me. Oh, he's for the only one I see. is very, very extraordinary. He's even more than anyone that you adore can love. He's all that I can give to you. Love is more than just a game for two. Two in love can make it. Take my heart, but please don't break it. Love was made for me and you. Oh, love was made for me and you. Oh, love was made for me and you. Thank you. Love. Special song, everyone. Baik, mungkin ada yang berkenan untuk bernyanyi, Bapak Ibu sekalian, sebelum acara dimulai kembali. Dipersilakan Bapak, mohon izin, mungkin mau bernyanyi. Oh, dengerin aja. Mau request lagu mungkin Pak? Dipersilakan. Baik, spesial request selimut hati, selimut malam berubah menjadi selimut hati. Aku kan menjadi malam-malammu, kan menjadi mimpi-mimpimu dan selimuti hatimu yang beku. Aku kan menjadi bintang-bintangmu, kan selalu menyinarimu dan menghapus rasa rindumu yang pilu. Aku bisa untuk mencari apa yang kau minta, untuk mencari apa yang kau impikan. Aku kan menjadi embun pagimu yang kan menyejukkan jiwamu dan kan membasuh hatimu yang layu. Aku bisa untuk mencari apa yang kau minta, menjadi apa yang kau impikan, tapi ku tak bisa menjadi dirinya. Aku bisa untuk menjadi apa yang kau minta, untuk menjadi apa yang kau impikan, tapi ku tak bisa menjadi dirinya. Aku kan menjadi malam-malammu, kan menjadi mimpi-mimpimu, dan selimuti hatimu, selimuti hatimu. Terima kasih. Special request selimut hati. Cukup. Baik, terima kasih.
aku bangga sih.
Dengan segala perubahan-perubahan.
Walaupun turbulence itu. Ya, sekarang kamu tutup matamu, terus nunduk ke bawah. Enggak, Yuk, recovery.
Gitu.
Tutup mata.
Ustaz atau siapa?
Ring level, close. Bakalannya skipnya lihat. Lu belum pernah nggak?
Paling seru tuh pokoknya jalan sama. Udah pernah latihan.
UPRT belum?
Altitud apa tuh?
Ya itu upset prevention and recovery training.
Belum.
High pitch, high bank. Ada normal pitch, high bank. Low pitch, high bank. Ada yang high pitch, kok banknya normal. Jadi pesannya normal.
Bagus ya, soalnya itu dari naikin sampai atas udah kan. Waktu itu harusnya udah di atas itu. Apa ada
Power close,
ditahan karena nggak pakai rem.
Power close, upset radar.
Powernya terakhir.
Iya, power terakhir.
Anu masih bingung.
Kan speednya kan masih tinggi.
Speednya masih kencang kan. Pakai apa? Pakai
elevator.
Kan kirain kan itu full bagus kontrol ya. Cuma
Ringan,
menikmati aja apa?
Ringan kan rasanya pesawat itu.
Iya. Terus tiba-tiba ngebarusin itu jatuh lepas. Ayo gimana?
Gue pernah bikin pesawat itu spin dan FI sih.
Gak sengaja. Apa?
Sengaja. Masuk buat spin. Dan instrumennya rusak. Langsung red F.
Good afternoon, ladies and gentlemen. Thank you for joining us again on this session, and we hope that you are now refreshed and ready to participate again on this event.
And now, we would like to invite back Mr. Baharawi to lead our session again. Time and place is yours, Mr. Baharawi.
Okay, thank you for the time. Bapak Ibu semua, ladies and gentlemen. Let's we start again our last session for today. Our last speaker or the fifth speaker will be Mr. Said Ahmed, PhD.
Hello.
Hello. How are you, Mr. Said?
Hello, good afternoon.
Good afternoon, Indonesia time. What
Very
about?
much. It's very early in the morning here.
Yeah, in Netherlands. How is Netherlands nowadays?
Full of snow and very cold right now.
Oh, okay. Okay, a little bit different with here. We are a little bit warm here in Indonesia.
Yeah.
Okay, ladies and gentlemen, our speaker will be Mr. Said Ahmed, PhD. As a tenure track assistant professor of system and control at the Royal University Groningen, Said is affiliated with the Engineering and Technology Institute Groningen and the John C. Williams Center for System and Control. He joined this position in December 2022 after completing 2 postdoctoral positions, one at the RUG with Jacqueline Serton, and the other at the Rhineland-Palatinate Technical University of Künstlerlauten, Landau, Germany. He completed his graduate studies at Central Supplic, France, and Bilkan University, Turkey, where he collaborated with leading experts in the field. His research interests span various topics in system and control engineering. From an application point of view, he is interested in designing intelligent control algorithm for autonomous vehicles, power system, DC grids, district heating system, and medical devices. From a theoretical point of view, he is interested in feedback optimization, observer design, stability and control of non-linear and hybrid switch and impulsive system, dissipativity and passivity analysis, and time delay system. He has published around 35 peer-reviewed papers at top journal and conference, and received the Best Presentation Award in the Control Robotic Communication Network category at IEEE Graduate Research Conference in 2018. And for this occasion, Said present the next gen aquatic airports engineering solution for aviation seaplane operation. So ladies and gentlemen, please welcome Mr. Said Ahmad.
Thank you very much for a very nice introduction. Let me try to share my screen, and this is always a difficult process. Let's see if I am successful. Is my screen visible?
Yes, we can see your screen.
Okay, perfect. Should I start?
Yes, the time is yours, and you have 20 minutes per presentations.
Sure.
And after that, maybe we have 5 minutes for the Q&A.
Okay. Thank you very much, ladies and gentlemen, for first of all for the chair of this session for a very nice introduction, and to the organizer for inviting me to this occasion. And it would be very nice for me to share some of our knowledge and what is happening in our research group, and to talk on this topic from a point of view of engineering and as a control engineer, electrical engineer, and autonomous engineer. So let's start with this. So my name is Said Ahmed, and I am an assistant professor at the Engineering and Technology Institute of Groningen. So we are the world leading center in systems and control, with a long history in systems and control, and nowadays in data-driven control. And today I will talk about the next generation aquatic airports engineering solution for efficient seaplane operations. So before start, let's discuss a little bit about the history of seaplanes. So the first seaplane, during the First World War, there were lack of suitable land plane infrastructure, and due to the lack of availability of vast motorboats, these were the two reasons that led to the birth of a seaplane. And the first seaplane was made by a French scientist, and it was called Le Canard. And it took his first flight in 1911 and 1912, and its shape resembled a duck. So in French, Le Canard is like a duck. So that's why it was called Le Canard. Then at the same time, an American scientist also formed a seaplane which was called hydroplane or flying fish, that took its first flight in 1911 and 1912. This flying fish become very, and nowadays as well in the US it's very, very famous, and people call it a flying fish as well. So at the very start, it took some issues during its initial takeoff due to suction forces, but that was later resolved. and by the implementation of a engineering technique which is called STEP. STEP means separating the forebody from the after body. So making separating the two bodies, and this plane, after resolving this issue, was called Navy Curtis. Then in 1947, the largest seaplane ever constructed was Hughes H-4 Hercules, which was also called Spruce Goose. And at the time of Second World War, since most of the motorboats were demolished during the war, so this was formed for transportation of material from the United States to Great Britain. And this was one of the largest seaplane ever created. Now let me take you, then after that there was some decline in seaplane research, which I will discuss in coming slides. But a good news is that an environmental friendly seaplane, electric seaplane, that is launched in 2023, though it is presented in Dubai, it was presented in Dubai for Expo, but it revived ideas for design for civil transport and tourism. It is basically for tourism, but it gives us hope that we can again continue research in this direction, which I will motivate as well. And this is an amphibious aircraft, which means that it can work on both water and land. And it has zero emissions, so it's very environmental friendly. It has 10 motors and an electric propulsion system supplying 180 kilowatt of power. It is able to fly for 2 hours with an extra 2 hours reserved at a cruising speed of 134 knots. And it is developed by JECTA, but you should appreciate that still with this electric design, it's only able to at maximum it can able to fly for 4 hours, which is indeed something that engineers have to work now to increase the flight time. So let's go step by step. So I introduce you to the history. Let me discuss you what are the functional requirements of a seaplane. So the functional requirements of a seaplane is that it should meet the buoyancy requirements. This is something that is different from the land plane. Land plane, because it has to land and take off from water, so it should have good buoyancy characteristics. Second is that it should have good takeoff and landing characteristics from water. And it should have a acceptable hydrostatic stability with the layer of water. It should have a structural support for both water and air. That makes it different from the land plane. But on the other hand, it should have good aerodynamic characteristics as well, because it has to fly as well. So even its land plane characteristics should be nice. So it requires knowledge from both aircraft and boat technology. Now, why there is a reason for decline in seaplane and why it is not in competition as compared to land plane? There are certain reasons that we will discuss, but we will provide some promising features as well. First is that the rules and regulation, it requires rules and regulation from both aviation and water for exact landing, stopping and maneuvering. And most of these regulations are conflicting sometimes, and this is one of the issue and one of the reason for the decline of this type of construction of this type of planes. Moreover, since there are lots of and large number of land-based runways, so landing on water is becoming less attractive. And because of the constant engineering research into speed and range of the land-based aircraft has increased considerably due to the advance in engine design and performance. So therefore, the commercial competitiveness of flying boats is has decreased in past few years, especially because they compromise, because their aerodynamic efficiency, their flight capacity is compromised somehow, because in order that it can have water based takeoff and landing, in order to allow that, the designer usually compromise on its aerodynamic or flight capabilities, which is one of its drawback. However, what is the promising thing? Promising thing is that it cannot compete with airline companies, but it can complement. It can add much more to the flight capabilities or to the airline by adding more routes in remote areas where land planes are inaccessible. And we will discuss it in detail in some few coming slides. Now, let me, before going into the design, modern design techniques, let me discuss the strengths, weakness, opportunities, and threats analysis of the seaplane operations and this water-based landing airports and takeoff. So first, let's consider the strengths. Number one, it's very versatile type of transportation, so it can improve tourism as well, and it can take you to places which are very difficult to reach, and it can be used for surveillance in inaccessible destinations. It can be used for monitoring wildlife and management of national parks, and it has very good safety record. So this data I took from a UK report that it has very few incidents during takeoff, landing operation, or related collision with boats. It can be used for sightseeing and tours. It can increase tourism in a place where there is large amount of water or islands, and like something like Indonesia. It has ability to conduct rescue operation over large body of waters. And why not boats? Because it's very fast as compared to the boats. And it can avoid the congestion on airfield. It does not require any land runway infrastructure. Unprepared landing is possible, and smaller landing fees as compared to the land planes. And as you can see, it can cover much more area as compared to about 70% as compared to the conventional land plane. Now, let's come to some weaknesses of this type of seaplanes. First thing is that they are of various nature, and they involve different aspects of seaplane or land and sea environment. So certainly the design of the engineering design of this seaplane is an obstacle on the advancement of this technology. And because of this innovative designs, because people have stopped its innovative designs, so they are only focused on visual flight rules, which means that when the weather is suitable, when you can clearly see, they can operate. However, in adverse weather condition or rough waters, it's very difficult for them to operate. One more point is that because of limited amount of seaplane bases and infrastructure, because people did not spend on their research for a long time, it means that maintenance of them, regular maintenance of them, is a consideration that need to be considered. So this is one of their weakness. However, what are the opportunities in seaplane research in modern era? So they are coming again into picture. Why? Because they have easy usability in places with lots of islands and area with many resources of water. For instance, like Greece or Indonesia or even England or Scotland. And they have faster service as compared to ferries, so they can make the connections faster. And they can be used for tourism because tourists enjoy it, because this is it's a different experience for tourists. And it can provide transport with quick dispatching, shorten travel times, And it has avionics system which lighten burdens on the pilot, help making correct decision and reduce human error, and night flight is also possible. Now, what are some more opportunities into research? So, one opportunity is to make seaplanes larger with more seas and less affected by weather and water condition. They should be some research is also like there is some gap in the research to make them efficient, safe, comfortable, and with more seaports, docking facilities, and they can do cargo operations. And one important thing is to, in order to make new, the existing land planes can be converted into them by adding the water facilities, takeoff and landing of water. This is very new type of research. And some material research, new technology, or amphibian design research opportunities are available. And they can add value to air transport by opening up locations to air travel where congestion on the airfields can be reduced and the significant time savings to the passenger can be achieved. Now, what are the threats? First, people might not be very open to this light aircraft because of light aircraft safety. So acceptance from population and environmental activists. So if it is not using electrical technology and it's traveling for a long time, then environmental concerns and some regulations should be loosen on flight time limitations that are from the avionics in order to make it more successful, which is a threat. And there is very lack of training and acceptability of dock operating crew, and this causes this lack of training and lack of staff is a big threat to this type of operations. Some other certifications are required from both water and flight agencies, some certain regulations. And most of the times, since in Netherlands we are also working, I will introduce you. So we are working on a micro simulation platform or micro simulation pilot that works for all land, sea, and also air. So this passing this regulation is a very, very difficult job. Then corrosion resistance, because they have to operate on water and they are very much dependent on weather conditions. So now let me go to design of seaplanes. What are the drawbacks in the traditional design, and then I will give you what are the engineering solutions in modern times. So the seaplane does not have to be optimized for aerodynamics, but also hydrodynamics, because it has to operate on water as well. So what are the drawbacks of a traditional seaplane? One is higher aerodynamic cruise drag due to additional structures, hydrodynamic drag while planning due to water wetted surfaces, and they have stability issues that come from limits on dimension and weight of the floating gears, and hindrance from water sprays, requiring special design shapes to divert the spray away, low performance in high waves and crosswinds, making smooth cruising in rough waters difficult, and maneuvering in water could be a deciding criterion, especially where narrow water strips pose a problem. Now, let us go to the new opportunities in engineering solutions that are available for seaplane operations. So this is a block diagram that what we can do as engineers, how we can make them successful, and we can run different algorithms. So first is, due to the advent of this machine learning and artificial intelligence, the optimization has seen a great revolution. Now you have a lot of data available and you can process data, and also due to this neural networks, a lot of neural networks based algorithms, the optimization has become very easy. So this is one of the a concept that I took from University of Scotland, but nowadays what we are doing is, at that time, machine learning was not in boom, but this optimization, when done with machine learning algorithms, we have seen a great boom and a great increase in the performance of seacrafts. So how this algorithm works? So first of all, what you do is, in this optimization algorithm, you first take the input from the designer, and this input is dependent on the specific mission profile of the aircraft or specification of the aircraft, that why it is being used. So first we consider only the land plane characteristics of the seaplane, that how it will work on the land, or and then we have this land plane optimized testing source code, and what it does is that based on this input from the designer, it provides an optimized sizes, the geometry and weight parameters, and then for every component this weight is calculated and the total weight of the land plane is obtained. Previously, in this thesis as well, in 2012, it has been shown that there are certain difficulties, but now we are trying to do this optimization by using neural networks and machine learning, and there is a significant improvement that can be done in engineering design of this and optimized operation and efficient operation of these seaplanes. So after this first step, after you have an optimized size for the geometry and weight parameters of the land plane, you move to the next part. Then this part is done. Then you go to the floating device segment here in this block diagram. And then based on the land plane characteristic, you take the inputs from the land plane geometry and weights, and then you calculate the weights and optimize the weights and geometry of the floating device. And then add this weight to the total aircraft. And the software for that is called floating device optimized testing source code. And there are a lot of engineering solutions or engineering research that is available in order to make this optimization easier, better, and more efficient by using this machine learning algorithms. Now, the final stage is that with the weights and geometrical features of both land plane and floating device, the design methodology combines both of them, amalgamate both of them, and then the final calculations are for the aerodynamics and water performance for validation. So from engineering point of view, there is a lot of room in engineering design from the optimization point of view, from the geometry, from the dimensions, both in land plane and docking device. And because of this new advent of machine learning, we see a great improvement and a lot of opportunities and promising, and we hope that the seaplanes will again become a modern technology. And let me reiterate that it still has these opportunities for rescue, for surveillance, for providing access to inaccessible areas otherwise, and it can add much more as compared to the land planes. However, some environmental concerns, some regulation from the authorities, and a nice engineering design is necessary for a successful and operation of efficient. And I think due to the increase in this machine learning, and I am very interested in this research as well. So with the advent of machine learning, we have a lot of improvement that we can do. With this, I would like to end my presentation, but let me introduce our lab. So we are creating one of the biggest autonomous systems lab that will take care of all types of vehicle in land, water, and air. And we are making a micro simulation labs first, and this lab will be developed from this will start from March. And this lab will be a national lab in Netherlands, and it is supported by national program Groningen, and it will be open to all national research and infrastructure, and we are going to do micro simulation testing for all types of vehicles. So this is quite ambitious. So I am taking the lead of that project from Groningen side, and I am co-managing this lab with Professor Bayu Jayawardena, who is also a professor at the University of Groningen. So we are supported by one of the leading companies in Netherlands in this cause, which is Robert Tuner and Green Dino. And we are also, our partners are Technical University of Delft and Saxon University of Applied Sciences and Hans University of Applied Sciences. So what we do, so Robert Tuner is our project lead and client for contractors, and we are providing nonlinear control algorithms, machine learning algorithms, and optimization algorithms for drones and vehicles that are equally good for water, air, and land. Then Green Dino is our contractor for hardware and software, and aerospace engineering at Delft Technical University is specialized in drones. And one of the interesting, this aerospace engineering at Delft Technology, you can see landing on the UAVs, landing on the ships, which is also, we are working on SLAM, how to make it more efficient. And then automotive research, Hans University of Applied Sciences and Saxion Universities will help us, and Data Foundation and Management and Administration of Open Resources, Data Foundation will take care of it. With this, I would like to end my presentation, and I would very humbly and appreciate this opportunity for even turning me into this presentation and for introducing myself. And I thank all the management committee, and thank you very much for inviting me. If you have any question, I will be more than welcome to answer them. Thank you.
Thank you, Mr. Said, for the presentation. Mr. Said Ahmed already presented about the history of the seaplane, and then the functional requirement of a seaplane, and the decline in seaplane operation, and also the engineering solution for optimized seaplane organization. So, do we have time still? Okay. Okay. If you have a question, please raise your hand and ask the question to Mr. Said about the seaplane operations. Is there any questions? Okay. Okay, Mr. Said, about the cost of operations compared to land aircraft and the seaplane, what is the difference, the operational cost for the seaplane? Is it a big difference or not so many different between the land airplane and the seaplane?
I think there is a huge difference, because from two point of view. First point of view is that the landing fees of seaplanes is much smaller as compared to the land plane, and which makes it versatile. However, if you this operational costs are low. However, the design costs, if you talk about design cost and you want to compete with land planes in other than operation, but also in design, then these costs are more, because other than only flight capabilities, it will have something to do with the floating device as well. And then but on compared as a whole, the landing capacities, the landing fees are much less for seaplanes. However, if you see that this cost, if you take about certain operations like inaccessible areas or something, and if you take all in consideration, so it's I think seaplanes, we cannot make a comparison very directly. However, we can say that seaplanes can add to the airlines. We need to have an operation where we both have seaplanes and land planes, and they will complement each other, and this will reduce the cost on the land planes as a whole.
Okay, and maybe last questions. What is your view about the seaplane in Indonesia? Is it will have good opportunities to operate the seaplane in Indonesia?
First thing is because I have seen Indonesia, I think there are a lot of islands, and it can be used for various different things, but some things that need to be taken care of, that how the always if anyone one wants to take a design of land planes, it is must to take this regulation into consideration, that how are this avionics and seaplane regulations. And I think this is the first step any person who wants to take this venture has to taken into consideration. However, I think it is very promising for Indonesia because of its structure, because of the islands and large I think it has a great potential for Indonesia, and it will contribute a lot to the economy and also to tourism and sustainable infrastructure.
Thank you, Mr. Said, for the explanations.
Thank you very much. Thank you very much again for inviting me.
Okay, we give a big applause to Mr. Said for the presentations.
Thank you very much.
Okay, we hope you enjoy the rest of the day, Mr. Said.
Thank you very much. Thank you.
Okay, and see you.
And I wish you a good afternoon.
Okay, thank you. And
Thank you.
sorry, please stay in the front of the your laptop, because we will have the ceremony for the presentation. Okay, I leave to the master ceremony for the next session. And Mr. Said, please stay, because we have the certificate presentation for you.
Thank you very much.
Thank you, Professor Said, for the enlightening session. As a token of appreciation, Indonesia Civil Pilot Academy of Banyuwangi, we would like to lively hand to you an e-certificate that will be shown in the screen.
Thank you
Please
very
give a
much.
big round of applause to Professor Said.
Yeah, maybe, and I would be very much appreciate if this can be emailed to me.
Yeah, we'll do, sir. We'll do. We will send.
Thank you very
Thank
much.
you so much for your very wonderful insight about seaplane and your enlightening knowledge about seaplane for us, so that we can apply it for our advancement of seaplane in Indonesia. Thank you, sir.
Thank you very much. Have a good day. Bye.
Once again, let us give a big applause for Mr. Said. And now we would like to invite Captain Daniel Dewantoro Rumani and Mr. Bahrawi. To Mr. Bahrawi, as a token of token of appreciation, we would like to hand you a certificate of appreciation that will be given by the Director of Indonesian Civil Pilot Academy of Banyuwangi. Okay, thank you to Captain Daniel and Mr. Bahrawi. You may return to your seat.
Ladies and gentlemen, we have reached the end of today's enlightening and informative seminar. We hope you all have enjoyed and benefited from the seminar and discussion of our distinguished speaker. Ladies and gentlemen, we would like to sincerely express our gratitude for their valuable contribution and for making this seminar successful. Moreover, We would like to thank our sponsor, organizers, volunteers, media partners, and all of our honorable guests for your participations and support. Please give a big round of applause to everyone who have made this seminar possible. And that is all from us. My name is Lucy.
And my name is Gede. See you on another frequencies. Goodbye. And to all of the participants and others, you may join into each of your breakout rooms. Thank you. Ya. Baik, kepada seluruh peserta kegiatan pada hari ini, dilanjutkan dengan kegiatan foto bersama. Okay, to all participants who attend via Zoom, please turn on your camera for a photo session. Thank you. Baik, dimohon kepada seluruh panitia untuk bisa berkumpul ke depan untuk melaksanakan sesi foto bersama. And we would like to announce to all of the participants who joined us via Zoom, the parallel session will begin at around 1:50 p.m. and for the participants who join us on site, the parallel session will begin in jam 1.50. We'll begin on 1:50 p.m. Thank you. Pada Taruna agar bisa berkumpul, Baik, untuk panitia yang berada di luar ruangan bisa mohon bantuannya untuk memanggilkan Taruna. Terima kasih. Siap.
Record.